Hey everyone, I'm Pat Topolinski from Engine Power. You know, we do a lot of cool engines for the other shops and they get to put them in vehicles and go out and have fun. Well, a while back we decided to do that ourselves. We took a 1973 split-bumper Camaro and we made it into a triple threat car, meaning it is at home on the streets or at the track. It was an awesome build and we had a lot of fun doing it. Hope you enjoy watching it.
You're watching Power Nation.
Welcome back to Engine Power. We are still on the road, this time in Kentucky, searching for our next project vehicle, a vintage Camaro. The seller told us the car was in great condition, and he wasn't kidding. Rarely does a car exceed expectations like this one did. We've come to the outskirts of Louisville to pick up our project for our triple threat car. Now, this thing is a true California survivor. It's never been hit or wrecked, and it's in almost pristine condition for its age. It is a 1973 split bumper Camaro, and it's gonna work perfect for what our plans are.
Now, what he means by a triple threat car is one that can be competitive on the road course, the autocross, and the drag strip. Now, we're not paint and body guys, so finding a car in this condition means a lot to us.
The car has had one repaint, but zero body work. From underneath to the interior and the vinyl top, we have to give this one a 9.5. It's original. There's no aftermarket parts on this car, period. But there's about to be. A triple threat car has to make big power, have an aggressive look, and handle excellent. For that, we need a seriously strong chassis, and we know exactly where to find one.
So we ventured south to the quiet little town of Grant in northern Alabama. It was settled in the late 1830s and named in honor of General Ulysses S. Grant. In the early 1920s, the Daughters of the American Revolution established the Kate Duncan Smith K-12 school due to the lack of access to public education in the area. The population today is about 907. It's also the home of our destination, Street Rod Garage. The owners are a couple of old friends. Mr. Sutton, how are you, sir?
Good, man. How are you guys doing?
Good,
Pat.
good.
Hey, Pat. Nice to meet you.
Nice to meet you, man. The place is awesome. I love the look. You know, it is a real shop. It's a real, when I think of a hot rod shop, this is a hot rod shop.
Well, that's what we're looking for anyway. That's what we try to do. You know, we building cars, building chassis, and got a good thing going here.
Cool.
I'm excited to be back. The feel of this place is awesome.
Now, I've never been here, and I need the nickel tour, so you're leading.
All right. Well, let's go this way. All right, guys. This is the body shop. This is where we do a lot of the metal work, all the body work, paint and body, all that. We've got several cars going. Camaros, Tri-5s, second gens, actually. So we've got a little bit of everything going on.
What's up with all the convertibles?
Man, it's just a run on convertibles. All this hot weather, I guess. Everybody's wanting convertibles. We've got several going. I think we got about 6 convertibles going right now.
So how many cars do you have here at any given time?
We're usually doing anywhere from 8 to 12. You know, we do trucks, cars.
How deep in the metal fab do you get? I mean, there's no limit?
This car started with a cow, and everything else is new.
Wow.
That says a lot.
That's right.
A family-owned rod shop that's been in business since 1979. The place takes you back in time to an era when life was simple and went by at a much slower pace.
We started building cars. There was 2 garage doors right here and a counter across the front where he's standing there. And we built cars and put them out front and sold them and stuff. That's how we started.
But the business grew and a new venture emerged.
That whole time, Chris was in the office just designing and building and coming up with ideas and theories and everything you can imagine for the chassis industry. I already had the car knowledge and knowing how to build cars and paint cars and body work. And then Chris was just a blessing to come in here and with the knowledge he had and start designing these chassis. And then the car and the chassis business merged together and just exploded.
And here's why folks come to Street Rod Garage for a chassis. What are guys looking for when they pull the stock chassis out and put one of these under? I mean, what is their main motive for it?
Well, they just want strength, and they're wanting to drive it like we drive cars now instead of like you would have driven that car, you know, back then. So they're wanting to beef it up strength-wise, and you know, looks is a lot of it now. You know, people want them to look nice and clean, just overall a nice finished product.
A lot of them are show cars, but they're also, a lot of people race these things. They drive them hard.
Definitely.
That's awesome. From car show cool, like this beautiful T-Bird, to the unconventional, a 1,500 horsepower blown Chevy pickup, which will have plenty of style once finished. He also has the obscure. This chassis was mystifying to us at first. We had no idea what went on top of it until Chris showed us some renderings. This one-off custom will be powered by a big inch LS engine backed by a 6L80E GM transmission. A 9-inch rear end is housed inside the unique shell. This head turner is headed to Russia.
David and Chris have perfected building hot rods and chassis since 1979. Now they share their knowledge with a new generation of hot rodders and tradesmen.
The fact that we take these guys, these young guys, and most of them come out of the school that's right here by our shop. And my wife's a teacher, my daughter-in-law's a teacher, and they handpick these kids, and they're good kids. And we take these kids and we train them, and we teach them how to weld, we teach them how to fabricate, we teach them how to do body work, and we give them something that they can take into life and use, you know.
Up next, from sheets of steel to a hardcore race platform, our Camaro chassis takes shape.
We're back and still on location at SRG in Grant, Alabama. It's finally time to build the chassis for our triple threat Camaro. Well, we've made it through the shop to the place where all the magic happens, if you will. And you've already got us keyed up, engine power 2nd gen Camaro. Tell me a little bit about your design process and what goes through to get some of this stuff from concept onto a computer so you can start working on it.
Well, the first thing we do is we actually buy a car or use a car for what we're doing. We shoot lasers under the bottom, we get all our dimensions, get it all plugged in the computer. And once we get the perimeter frame done, as you can see some of this up close, once we get the perimeter frame design done, we start putting wheels and tires in. Then we start bringing in suspension components and things like that into the drawing. That's one of the things that's really helped us in the last 15 years is just technology, the use of it. Being able to look at things before we actually start cutting metal. Metal's not cheap, so we want to make sure that it's going to work before we do it.
Chris is able to lay out all the pieces for the chassis, including the brackets. No preformed tubing is used. He cuts everything out of flat plate. When he commands the torch table to cut, what you see on the computer screen comes to real life. As the torch makes more and more cuts, notice how the layout is exactly like it was on the monitor. The layout also helps eliminate waste by using as much of the steel as possible.
Chris has perfected the setup of the machine, ensuring super clean cuts and minimal time afterwards to remove slag. What's impressive is all the chassis are cut out on this 4x4 foot table. When the torch stops, the pieces can be handled.
And it's already cool enough we can touch it.
The first panel to be worked on is prepped for welding. A quick pass with the grinder around the edges will ensure clean welds with good penetration. Now 2 sections are set up on a jig and a straight edge is used to align them before tacking them to the table. Next, a couple of fabrication squares are used to get the rail to the next step, which is forming the top portion of the rail. This is done by hand, bending and tacking the piece as it falls into place. Repeatedly through the entire process, the rails are checked for straightness. Adjustments are made with Thor's hammer. Well, kind of. It's a tool they fabbed up in-house. Once the sides and interior gussets are added, here's what a section of the rails looks like. The cross members are built in a jig, then finish welded on the table. A mix of MIG and TIG welding is used. With what we have planned for this car being a triple threat car, wanting to do it, using it in a couple different deals like that, what's your recommendation for rear suspension?
I'm thinking we go with a parallel 4-link with just a panhard. We'll keep it simple, give you tons of adjustability in it for whatever you're going to do with it. We can get real elaborate with it, but I think for what y'all are going to do, that would be the simple that fits well. Going to be easy to work with.
Every chassis is finished off with the needed bracketry, which is tacked into position, then finish welded with heims in place for perfect alignment. When the guys finish up, you have the option of a bare or powder-coated chassis.
If we do these chassis hands-on and we individually watch each one of them be built and examine the welds and make sure everything is built, like it should be built. I feel better when I lay down and sleep at night that I built a good, safe chassis, and I feel like that our product is quality. I feel like it's strong. I feel like we really have something we can be proud of.
Our chassis will be ready soon, and we can't wait to see it under our Camaro. There we go.
You want me to squeeze in there?
Yeah, hey, see if it fires up.
2 pumps?
Give her
Ready?
2 pumps.
Here it goes. Look at that.
See? Come on out.
We've talked about triple threat cars before. Now we're going to talk about exactly what they are and how to build a competitive one. 3 of the most popular types of racing these days are autocross, which is basically cones set up in a large paved area mapping out a track. Road racing, which is done on large corner carving courses, and drag racing. No explanation is needed here. Simply put, a triple threat vehicle can handle all 3 and be competitive in its respective class. These vehicles need a strong foundation to handle the abuse. That's why we chose to put a Street Rod Garage custom chassis under this Camaro. Now that will allow us to run a larger tire size, have a lot more adjustability with the suspension components, and have a much more rigid and predictable driving experience.
The heart of any high-performance vehicle, especially a triple threat car, is the power plant. This being a 1973 with a stock engine, it came with an L65 2-barrel 350, which made a romping stomp on 145 horsepower and 250 pound-feet of torque. Our goal is to triple or even quadruple the power in this car, and that would be tempting to do with a big block, but because this car is going to see some autocross action and it needs to be more balanced than having a big heavy engine in the front, we are going to do it with a small block. It's a bit on the exotic side.
The balance topic continues with these parts. A quality coilover setup is a must. We need to be able to change the car's ride height and adjust the rebound and compression of the shocks. I consider these the heart of the suspension system. Next is this manual quick ratio steering rack. Being able to achieve lock-to-lock steering positions faster will be a huge help on the track. Brakes are also a balance issue. Fast cars need a braking system that is sufficient with the weight and speeds the car is capable of. This 13-inch system is definitely a good choice.
These upgrades are just a part of what goes into planning a true triple threat car, and we still need to address a few other things like wheels, tires, safety equipment, and more.
Plus, we're going to keep the classic look of this split bumper Camaro, but we've got a few ideas to update its style. Now you'll be seeing more of this car on future episodes of Engine Power. We just wrapped up the short drive to the south side of Nashville, Tennessee to our location, Shacklet Auto Machine. This is where the block to our 73 split bumper Camaro is waiting. Now this is a unique high-end piece from World Products. It's unique in the way that it's a small block Chevy on the bottom end and it accepts LS induction up top.
Machine shop is one of my favorite places in the world, and if you've never seen the inside of one when you've dropped off your project, you're in for a treat. We're going to go inside and see some actual machining operations like boring, decking, and some honing, so let's go inside and check it out.
For almost 20 years at this location, Shacklet Auto Machine has been keeping things running, from farm tractors to race cars and everything in between. The building is filled to the brim with equipment, but more importantly, plenty of engine parts waiting to be machined.
I've been a machinist pretty much all my life, helping my dad. My dad taught me and helped him in the garage and now here at the business. We do a little bit of light diesel stuff, imports, domestic, race stuff, high performance, marine, that kind of work.
Our 440 cubic inch Motown LS Bullet is not a bolt together operation out of the box. Like any engine designed for a specific application, tolerances and sizes are determined by the engine builder. And that's where a quality machine shop comes in. Our World Products Motown LS block comes semi-finished in a few respects. One is the bore and the other is the lifter bores. Now, they come at 4/120, and if we wanted a finished bore size of 4/125, well, we could just put the thing in the hone and be done. But we have a big bore size, 4/185, because we're going to a big cubic inch, so a few machine operations have to get done first. One, stick it in the boring bar and taking out a bunch of material. And this is where most of the material is removed, on the boring machine. Because of the large amount of material to be removed, John is doing it in 2 passes per cylinder. First with a roughing cutter, and then a second pass with a finished size cutter. This will leave 5 thousandths of material to remove later in the hone.
After boring the cylinders, the block is ready for decking. An alignment bar goes through the mains and sits in V-blocks on the machine. This ensures that the deck surface being machined is parallel with the center line of the crankshaft when finished.
Yeah, we surfaced the block using the CBN cutter, square decking the block to make sure our deck heights were the same on all 4 corners.
There's only one cutter used in the machine. It's a small puck made of cubic boron nitride, or CBN. This material is so hard and durable it will last for 6 months of heavy cutting. Only about 3 thousandths was removed from each side of our block, leaving a super nice finish for the head gaskets to seal against.
The final step in machining the cylinders is honing. A torque plate is bolted up before final honing. This simulates the distortion of the top of the bore when the cylinder head is torqued down. The torque plate ensures the cylinder is round when the engine is assembled. Just like he did when boring the cylinders, John decided to do it in 2 passes per cylinder.
We roughed in the cylinders with the 625 stone, which is a 280 grit, finished the bores with a 400 grit. I just decided to do the 2 passes so we could take out the majority on the first cut and have a little bit nicer, smoother finish on the second cut.
As he works, John checks the diameter of each cylinder with a bore gauge. During honing, the cylinders develop a distinct crosshatch pattern. Oil is held inside the crosshatch sections, which helps lubricate the piston rings sufficiently. When professionally done, crosshatching also helps seat the rings properly.
The other semi-finished part of this block is the bronze lifter bushings. They must be sized with the hone for final fit.
That's on a bronze bushing of roughly 0.8 to 1/1000 lifter to bushing clearance.
For peak performance from any purpose-built custom engine, precise, accurate machine work is a must. We are fortunate to have a great machine shop just down the road.
In the end, you're trying to achieve everything, the right clearance and geometry for everything to work the way it should. Clearances and that kind of stuff.
Now on to the next order of business, which is our 73 Camaro. Pat had to step out for a little bit, so Jeremy and I will be handling this dyno session. Now this car is as original as it gets for being 45 years old. Back in '73, GM dropped the SS model and replaced it with the LT, or luxury model, like we have. Now it came with a wood grain dash, better insulation, and additional lighting.
Now the 5th digit of this car's VIN is a K, which means it has the L48 engine and has a 4-barrel. It made 175 horsepower and 280 pound-feet of torque. So let's see what it puts down on the rollers today.
Everything good on your end?
Everything's good, man. You're good to go. She was screaming that time. So we're at about 126 on power, 195 torque.
Staying pretty consistent.
Yeah, it's staying right in there. I'd say, for that, that's not bad.
45-year-old wore out 350.
Absolutely, man. Yeah, I'd say you probably can't complain too much about that. But what's the game plan now? What's the goal?
The reason we did this is to get a baseline, because the engine we have planned for this car, it's going to be 440 cubic inches, and it's a hybrid, so small block Chevy bottom end accepts LS induction up top.
Man, yeah.
But on paper, the engine's going to make 680 to 700 horsepower. So we're knocking on the door at 7 times the power of what it makes now.
Yeah.
So,
well, man, that's going to make it a fun car then. There's no doubt about that. Have fun on the street. That's definitely improved there for sure.
Yeah, and the chassis is going to be able to handle it. We're putting a one-piece chassis underneath it, a 400 trans, so it's going to be a really good combination.
Well, look, when you get all that done, I'm going for a ride, so you come get me.
A night in downtown Nashville, buddy.
There you go.
Thanks for the help.
Yeah, man, you bet.
For more information about the parts and equipment used in today's episode, visit PowerNationTV.com.
Now that you have an idea of the engine for our triple threat car, it's time for us to start making room for all of those new parts. Now, we have never started a major project with a vehicle that's actually this nice, but that's what's going to make it easy to work on with all of the major things that we have planned.
All of you purists have got to be squirming in your chairs at the thought of us cutting up this beautiful car. Don't worry, we have the same respect for it as you do. That's why the vast majority of the interior and the exterior are staying the same. Our improvements are based on functionality, which include acceleration, braking, and handling. With a little protection under the corners, we'll start by removing the hood. It'll keep Pat from getting a head injury when he works, and make it easy for us to lift the engine out. That thing's pretty heavy.
It's not horrible.
The air cleaner assembly can be pulled off, along with the fan and shroud. Here's a quick tip. With the coolant draining, I'm forcing compressed air into the heater core hose to push coolant out of the core. This helps get most of the coolant out of the entire system more thoroughly.
The stock Rochester Quadrajet, which some people call a Quadra Bog, is removed. Okay. Even though the engine is coming out, practice makes perfect. The carb pad is taped off so nothing gets in the engine. Now we'll pull off all the accessories. Let me get this belt out, okay? There you go.
Just in the nick of time.
All right, there you go. Underneath, the trans cross member is unbolted, and with a little whack-a-mole, it comes out. And once the trans is removed, we get another reminder of how solid this car is. Just look at this trans tunnel.
The more we removed, the more excited we got. Other than regular maintenance, it's evident this car has been unmodified since it rolled out of GM's plant. No signs of performance parts or hack work can be found. This is going to be one sweet ride when we're done with it. For more information about any parts or equipment we use today, log on to PowerNationTV.com.
Welcome to Engine Power. Today we're getting back on our triple threat project, which is this 1973 split bumper Camaro that we will be taking to our annual barbecue and burnouts competition later this year. Our version of a triple threat car is pretty straightforward. It has to be a street car that lays down big numbers on a dyno, turn in respectable lap times on a road course, and run the quarter mile in stellar fashion.
That car is what I call a survivor. It's unmodified and was owned by one woman pretty much its entire life. Now, she worked for Tiffany & Company in New York City and bought the car brand new. That explains the factory undercoating. Within 1 month, she was transferred to the Southern California Tiffany location, and she showed up with her old Camaro in tow. Now, in the mid-1990s, the car was almost destroyed by wildfires. Now, it did have some paint work done because it was damaged, but there was no body work done. Now, the car then was sold in 2015 to a gentleman in Kentucky. Last year, it came up for sale again, and hey, we couldn't pass it up. That's why it's in our shop.
The power plant for a triple threat car has to be stout, and with that in mind, we wanted to do something a little bit different than a conventional small block Chevy or LS setup. So why not combine the two for a super solid foundation? We'll be using a World Products Motown LS block for that, and here's a quick look at what we had done to it. After arriving from Summit Racing, we hauled it to Shacklet Automotive Machine in Nashville, Tennessee. There, it received several machining operations. The cylinder bores were bored and torque plate honed to 4/185. The decks were also equalized to 9/240. The align bore was checked and found to be right on the money from World Products. Here's a look at what this block is all about.
Now, this block accepts small block Chevy parts from the deck down. from the deck up, it's all LS induction. Now we ordered this with all the items needed to finish it off, plus a bunch of other parts.
Even though it's back from the machine shop, there's still some work to be done. A brand new block still has a lot of sharp edges from being machined, so we're going to spend a few moments deburring them. Also, we want to improve some oil flow, so a couple of different areas will get some attention to help that process. Here's a look at the items we'll be using, and the most important one here is safety glasses. To get the job done, grinders, a variety of carbide burrs, and cartridge rolls will be necessary. I'll start by deburring all the sharp edges using the die grinder and a carbide burr. The object is to remove only enough material to get rid of the sharp edge. Using very light pressure and keeping the burr moving is key. Here's a before and after look at what it does. For oil passages, a sanding roll is used because it's less aggressive and creates a smoother surface finish. To promote a good seal, a disc sander with a Scotch-Brite pad is run over the oil pan rail and other gasket surfaces. The next step involves a thread chasing kit from Matco. Even though this is a brand new block, I'll still chase every threaded hole. Chasers differ from taps in that they only remove dirt or machining debris from the threads instead of cutting new ones. Be sure to do this by hand, because it is tempting to use an impact driver or a drill to speed up the process. Getting too crazy with it can accidentally damage the threads, or worse, break off a chaser in the hole, and then you have a real problem on your hands. Next on the to-do list is gapping the piston rings. Our Goodson ring filer makes this job go quick and accurate. We fit the ring sets to each individual cylinder. According to Molly's chart, included with the rings, naturally aspirated circle track and drag race engines require a minimum end gap of 5 thousandths per inch of cylinder bore on the top compression ring. Our gap is slightly larger due to the fact that we may or may not run a small shot of nitrous. So 22 thousandths is our target. Here's a tip. When filing rings, always file the second compression ring first. This will give you a chance to verify the accuracy of your grinds since the top ring gap is more critical. When checking the gap in the bore, make sure to use a ring squaring tool to get accurate and repeatable readings. The oil support rails need a minimum gap of 15 thousandths, so be sure to check them as well.
Engine power is all about its name today. We're going to start by assembling our 440-inch Motown LS for our triple threat Camaro project. Now this is World Products engine block that utilizes small block Chevy parts from the deck down and LS induction upstairs. This engine will give us the best of both worlds, strength down low and airflow up top. The last time you saw this block, Pat was prepping it for assembly. That included deburring all of its edges with a die grinder and carbide burr. He also blended the areas where the oil filter rides. All that grinding means the block has to be thoroughly cleaned. Luckily, we have a commercial type block cleaner. If you don't, soapy water and the water hose will get the job done. The block will stay in for about 40 minutes. Once out and dried off with compressed air, the engine goes back on the stand and gallery brushes are used to clean all the oil galleries. This one looks great. A final wash cycle will have it ready for assembly.
The next operation is installing the cam bearings. Now you've seen us do this with our installation tool and a hammer, but not with these. These have more press fit for this type of engine, and I have a solution to put them in. Because of the high amount of press fit, trying to pound these bearings in with a hammer would absolutely damage them. So I'm fabbing up some bearing installation pucks on the lathe. That way I can pull the bearings in evenly without damaging them. With less than $20 worth of threaded rod, nuts, and washers from the hardware store, we have an effective tool to get the job done. 2 pucks on either end of the engine hold the threaded rod in alignment with the cam bore. A puck goes in the bearing, and a nut holds it in position. As I tighten the nut on the front of the engine, the bearing is gently and accurately pulled into position. Once the bearings are oiled, we'll drop in the Eagle crankshaft to do a little mock-up. Even though the block has been clearanced from the factory, we'll double check to make sure everything is good. This crank has a 4-inch stroke, but the rod bolts clear the bottoms of the cylinders by a mile. Mahle Motorsports is the official piston, piston ring, and engine bearing provider for us here at Engine Power, and for good reason. They make some of the best parts in the industry, starting with their pistons. Interestingly, this is a shelf stocking part number, which shows how popular this build is. These are made from 4032 low expansion alloy, have a 4/185 bore, and the valve release fit our particular LS head. They're a slipper skirt design, and the finish operations on these pistons are done on piston-specific machines that are designed by Mahle. They have an advanced skirt profile, which increases strength and reduces drag. The profiled pin bores increase strength, allow for lighter designs, and eliminate the need for final honing. They are coated with a phosphate dry film and Mahle's Graphel skirt coating that reduces drag, wear, and noise. The ring grooves are 1mm, 1mm, 2mm, and the top ring is hard anodized to prevent micro welding. The high-performance ring pack is included with the piston kit along with heavy-duty wrist pins. The ring's thicknesses match the piston ring lands at 1mm, 1mm, 2mm thick. The top ring is constructed of steel and has Mahle's patented HV385 coating on the face. The second ring is also made out of steel but has a Napier face for better oil control. And the CP20 oil ring set is designed for low drag. We're also using their Clevite H-Series main and rod bearings in this rig. Now, these were originally designed to work in NASCAR engines to handle the stresses of high RPM and high horsepower. Ours are narrowed from the factory to work with our crank, which has a larger radius in the side of the journal, and they are also coated to reduce friction and damage from cold startup.
Welcome back. Eagle Specialty Products has been offering complete rotating assemblies and individual components for engines with all types of power levels since 1992. This is one of their 4340 Ford small block Chevy crankshafts with a 4-inch stroke. It's been ESP armor treated, which is a process that promotes oil shedding and strength. 125 thousandths radius is put on the main and rod journals, and it has cross-drilled and chamfered oil holes for better oiling. And each crankshaft undergoes extensive testing at Eagle to verify that you get a quality product. Complementing the crankshaft are Eagle's forged 4340 H-beam rods. These have a 6/125 center-to-center length and accept a 927 thousandths diameter pin, which rides on a bronze bushing. ARP 2000 rod bolts are installed, which have a higher tensile strength than a standard 8740, making them much stronger.
We've already checked all of our bearing clearances, and here's a quick look at the numbers. You can download one of these sheets for your own engine build on our website. With our Clevite bearings lubed up with Royal Purple Max Tough, the forged Eagle crankshaft can be laid in, followed by the billet main caps. They locate on dowels and will be secured with ARP hardware and lubed with ARP's Ultra Torque for consistent torque values. Final torque is 70 pound-feet. Next, our thrust clearance is checked. It comes in at an outstanding 5 thousandths. Now the pistons are ready for assembly. Both the rod and piston are thoroughly lubed with more Max Tough. The pins are retained with wire locks. They can be a bit difficult to put in, but after a few, you'll get the hang of it. Our 1mm, 1mm, 2mm ring pack gets put on each piston. Be sure to stagger your ring gaps during installation. The rings rotate slightly during engine operation, typically at the same rate. Having the gaps staggered helps ensure that gas pressure stays in the combustion chamber where it belongs. Some special piston ring and skirt lube coats the assembly, and the piston drops into the adjustable tapered ring compressor. Next, we carefully install the piston into the bore, making sure the ring compressor is seated against the deck. Then it's lightly tapped in with our dead blow piston knocker. The rod cap is lightly snugged up to keep everything in place. Making sure the rod bolts are loose, our ARP rod bolt stretch gauge is used to check the length of the fastener. Zeroing the gauge is a must. The bolts are torqued to Eagle's spec of 75 pound-feet, then the bolt stretch is checked. This ARP 2000 fastener should stretch between 64 and 68 10,000ths. We're showing 65 10,000ths, so we are within spec. This procedure is repeated for every rod bolt in the engine because arguably it's the most important fastener in the engine. And next time you see it, we're going to be sticking the camshaft in and doing some valve train work, and you really don't want to miss that.
When you're building a race car, you need a solid foundation. Today on Engine Power, The high-performance chassis for the triple threat Camaro receives a deluxe powder coat finish, along with fully adjustable race suspension. Plus, sometimes the best roadmap for your project is a good rendering.
Welcome to Engine Power. Today is all about our triple threat Camaro project. From the chassis to the power plant, we're gonna make some progress. But a while back, we went down to Grant, Alabama to see how the process of a chassis build takes place.
Hey Pat, nice to meet you.
Nice to meet you, man. After showing us around, owner and designer Chris Sutton showed us how our chassis comes to life. From computer design, to cutting steel plate, to building the frame rails.
Engineering and building a chassis is not an overnight task. It takes time and requires a special skill set in fabrication and mathematics. A few days ago, we got a call from Chris, and it's the call we've been waiting on, letting us know that our chassis was ready to pick up. Chris, this chassis looks killer. Awesome cross members, additional bracing, and this contraption back here, that is one good-looking four-link.
Thank you. It's a lot of design in that to get it all in the compact area there with, adjustability for the triple threat car and actually something that'll work. So,
do you have any guys that take these chassis out to the drag strip?
Oh, absolutely. Drag strip, autocross, road race, just street cars, but everybody now wants them to perform like a autocross car, a drag car, even on the street.
So you're inadvertently building triple threat cars all the time?
Pretty much, yeah. Yeah, as many of them as we do, to see it on a computer screen and then to a full built chassis is really impressive to us, and we're the ones doing the work. Many hours that you put into it, it's just gratifying to see it, when it's ready to go out the door.
I like it. Something else that's pretty cool, you think with, all the additional look of the steel and that with a full chassis, that it would be a lot heavier than, the factory subframe and the rear suspension, but that's not the case really, is it?
Oh, no. Actually, when you weigh the front subframe, the factory rear suspension, and then what we do with the frame and the different suspension and making everything smaller and more compact, we actually come in lighter than the factory suspension.
From Grant, we headed to Goodlettsville, Tennessee, where our chassis was scheduled to get some color. Mr. Speed Coatings has done stellar work for us in the past, so we wanted them to continue the tradition on our projects.
James Terry has been powder coating for over 40 years. He's seen it grow into a widely used, reliable finishing method, offering strong protection, a sleek finish, and a major reduction in volatile organic chemical emissions.
Because of the VOCs and liquid materials, the EPA is coming down on these liquid coaters, and powder is essentially a green coating, so you don't have any VOCs in the atmosphere. And it's much more durable. Powder coating, you can actually, you can get pretty much a powder coating price the same as a liquid price, but it's a whole lot more durable.
The name Mr. Speed Coatings came from a nickname given to James, and you couldn't pick a more appropriate moniker than Mr. Speed. Like a shark, he always seems to be in motion for hours on end. From the booth to the baking oven, James constantly juggles multiple coating projects at a time.
I love what I'm doing. I praise God for what He's gave me, and I'm glad to be here every day. And when I go home, I'm thinking about work, what I'm going to do tomorrow, and I love being at work. I love working.
Mr. Speed Coatings recently moved into a much bigger building, right next door to their previous location. Although some have encouraged James to install automated equipment, he's not sure that he would ever do that. He simply enjoys the hands-on work of powder coating too much.
I'm not in it to be rich. I mean, I'm passionate about what I do. People ask me all the time about what about your competition? I don't care about the competition. I worry about what I do. Somebody else wants to do something different, let them do just something different. But I do what I do, and everybody else can do what they do. I don't care.
Up next, our triple threat chassis gets a triple layer finish, and it looks incredible. Then we'll load it up with race-ready coilovers, a 9-inch rear end, and more.
We're back on Engine Power, making our second visit to Mr. Speed Coatings. James Terry and his son Daniel specialize in high-end coatings for automotive and commercial products. A few days ago, we dropped off our triple threat Camaro's chassis to be prepped for powder coating, and we're back to see how it's progressing. James, it looks a little different than when we brought it in. It was bare steel. Now you've got it to the point of being actually primered. Tell us what your prep is.
Sandblasted, and after we sandblasted, then we chemical prepped it, and after we chemical prepped it, then we dried it, brought it back out, and put a light coat of primer on it.
What does the chemical do?
The chemical actually is iron phosphate and a cleaner, and it actually cleans the part and puts a thin layer of iron phosphate on it.
Good deal. Now, is this a self-etching primer or just
Yeah.
Okay. Good deal. From this point, what are we doing next?
We fix and put it in the oven and preheat it and bring it back out and then put it in the booth and shoot some powder to it.
Get some color
Put
on
some
it.
color on it.
Powder coating sticks to the metal surface based on electrostatic attraction and can be done with the metal at room temperature. However, especially on primered metal, James finds he gets more consistent coating by spraying the coating onto preheated surfaces. We opted for a finish called gunmetal. It comes out of the booth with a fairly deep color, but later, after clear coating, it will develop a lighter, more silvery hue.
After powder coating the accessories, James bakes them for a few minutes in the oven until they are partially cured. After letting the pieces cool down, he applies the clear coat. The result? Phenomenal. Oh, man. Look at that. I mean, it looks wet. Yeah. It looks wet.
Yeah. That looks incredible. Yeah, primer, a color, and a clear coat, so it's like extra protected.
It'll be here when we're gone.
Next, the clear-coated pieces finish curing in the oven, and it's on to the chassis itself. A headlamp helps James make sure he's laid down a solid, even coat. After partially curing in the oven and cooling off, the chassis receives clear coat. Finally, it's cured in the oven for about 15 minutes at approximately 400 degrees Fahrenheit. The end result looks great. A glossy, thick finish with excellent protection for the chassis. After cooling to room temperature, the chassis is ready to be loaded up and taken back to the shop. Alrighty.
Assembly of this killer street rod garage chassis starts with the front lower control arms. They're a tubular design with heim joints and have a gusseting plate that doubles as an adjustable shock mount. The uppers are also tubular and have screw and ball joints just like the bottom. All this hardware came with the chassis. For mock-up, these spindles are being used. We have a set of Wilwood's Pro spindles on the way. With the fresh coating, there is a little prep work to be done on some of the through-bolt holes. The powder and clear coat slightly reduces the size of the hole, so a little cleanup with a cartridge roll is necessary.
The 4-link setup goes in next. These are the heims for the upper 4-link bars. They use spacers to keep them centered in the chassis. For smooth operation and insurance against galling, anti-seize is used on all of the ends. Now the upper bars are attached to the heims, and the lower bars have the same protocol. There is a left and right hand thread which allows for length adjustability without removing the bars. Now the Fab 9 housing can be positioned under the chassis. This part. Oh, there.
Watch the powder, Freddie.
It'd be all right.
Just for right now, let's set it in middle bar.
Set it middle. Might have to
Middle.
middle.
Bottom.
Yep. The bars attach to the housing with more spacers and hardware from Street Rod. So it's just that easy. It's like a new gym technique right here.
Down a little bit. There you go.
That's it right there.
Yeah.
These beefy and well-built brackets are for the lower shock mounts. Next is the panhard bar, or as some call it, the track bar. Its job is to provide lateral location for the entire axle assembly. Back up front, the custom fabbed engine mounts attached to the chassis. These are for an LS engine and are adjustable. The trans-cross member is also fabbed. It's fully adjustable and, like everything else, it fits absolutely perfect.
Coming up, more performance pieces for the Camaro, and we'll draw inspiration from a guy who really knows how to draw.
We're back and fitting up the front sway bar. This is built in-house at Street Rod as well and is held in place with urethane bushings. We needed some spacers made to mount the rear coilovers. No calls were made. Just a quick conversation with Pat, and he was making them on our MSC Vectrax lathe. He's cutting them out of aluminum bar stock that we got from Metal Supermarket. These are the finished product. They will space the top and bottom of the coilovers evenly inside the brackets. QA1 Promo Star double adjustable coilovers are going on. These have independent rebound and compression adjustments, 18 on each to be exact. Each click has been carefully defined to provide the ideal force curve to maximize performance. Constructed of lightweight aluminum, they have a 3-step sealing system and are 100% dyno tested and serialized.
The mock-up spindles are removed and the new Wilwood Pro spindles are installed. Now the front coilovers go in. They are the same as the rear, but use a different spring rate. The rears are 250 pounds, the fronts are 550s.
ARP stainless hardware will keep them anchored. Composite paper gaskets like this are well known for wicking fluids from the inside out, developing an external leak. Lube locker differential gaskets will eliminate that thanks to the aluminum core and the outer silicone coating. Now the sealing secret actually comes from the elastomer beading that is applied to the gasket face. These gaskets install dry, no silicone is required. Another benefit is they are reusable and no cleaning of the surfaces will be needed.
A triple threat car arguably takes more abuse than a dedicated drag or circle track car. Not only does it have to take the hard launches on a drag strip, but the constant loading and unloading stresses of a road course or autocross. Now, to handle all that pounding, we decided to go with a Strange Pro Series nodular iron 9-inch Ford case. Now this thing has a 250 bore that accepts 35 or 40 spline axles, has additional mass for strength, chrome moly caps, and it's machined by Strange right here in the USA. Inside is an Eaton Detroit locker differential, and to strike a balance between acceleration off a corner or down a drag strip, we chose a 4:11 gear ratio.
Up next, strong stoppers for our race chassis.
Whenever you're planning a project, our rendering helps you get a good idea of what the finished vehicle is going to look like. When we mentioned our split-bumper Camaro to him, Daniel Maffett sketched out a brilliant design for our triple threat race car. Recently, he stopped by the shop to discuss his creative process. So Daniel, how does it get from a couple of goofballs giving you an idea to something that comes into exactly what we had actually pictured? You're kind of like a forensic artist for crimes, but only you're doing it for something benevolent like a rendering for a car. So
when someone brings me an idea for a car, they bring me a bunch of elements. And I have to take all those pieces of the puzzle and put them together in a really cohesive design. And then you do a line drawing. And if the line drawing looks good, then you move that into block and you do colors and start adding some features in there. If you don't have a color scheme, you do just a real simple line drawing, throw a bunch of color schemes down and compare them. And once you have a direction, then you move into a full render like this where it's a little more detailed.
What's the usual time frame to get one on paper like this?
So once you have the line drawing done and all the ins and outs are planned, it takes about 2-3 hours to do a full rendering.
now you work on a few cars yourself. Do you have anything in process of your own?
My wife and I have a 66 Chevelle that we're doing for ourselves. It's an inherited piece. It was her uncle's. We're redoing it and we're gonna make a nice cruiser out of it.
Well, man, you've done a great job, and now you set the bar extremely high for us, because now we're going to try and make it as close as we can to this rendering because we love it so much, man. So thank you very much. We really appreciate it.
Thanks, I appreciate the opportunity.
And with Daniel's vision to inspire us, work continues on the triple threat Camaro's chassis. First, the backing plates that house the emergency brakes drop onto the rear axle flange, followed by the axle shafts. These are 35 spline and fitted with a Ford big bearing end.
There we go.
These high-end two-piece rotors came with the fasteners already drilled to run safety wire, so we're taking advantage of them for an extra degree of safety. Although a time-consuming operation, this is cheap insurance and peace of mind for a car of this caliber. Now a centering ring goes on the axle, and the 13-inch rotor slides onto it. The rear caliper is a 4-piston design made out of billet aluminum. The pads go in next and are retained with a shaft and through bolt on the top side of the caliper.
Up front, a billet caliper bracket attaches to the Pro spindle, and the front rotor packed with bearings can slide on. The next time you see this project, we're getting back on the engine build. Make sure to keep an eye out for it. For more information on anything you've seen today, drop by PowerNationTV.com.
Today on Engine Power, it's put up or shut up for our triple thread Camaro's power plant. The hybrid LS engine receives a race-ready timing belt setup, an aggressive cam, and more. We can't wait to see the numbers on this baby.
Welcome to a brand new episode of Engine Power. Today we're going to let the chassis and body of our 73 triple threat Camaro project take a little rest. The last time you saw it, we picked the chassis up from Street Rod Garage, hauled it to Mr. Speed Coatings where it got some killer powder coating work done, then brought it back here to the shop where we assembled the rear end, all the suspension, and finished it off with a big brake kit from Willwood.
Today is all about the triple threat bullet. We are going to assemble this engine and get it strapped to the dyno to see how much power this potent combination will put out. And we also have a plethora of performance parts from top manufacturers so we can optimize the output of this 440-inch combination. And we've already done a bunch of work to it. Take a look. We started the build with a World Products Motown LS iron block. It's a blend of original small block Chevy design down low with a deck that accepts LS cylinder heads. This one has 350 mains, a 4/185 bore, and the cam tunnel is raised 134 thousandths for excellent valve train geometry. The crankshaft is an Eagle Specialties 4340 forged steel piece with a 4-inch stroke and ESP armor treatment. H-beam Eagle rods with a 6/125 center-to-center length make the link to a set of forged moly pistons. They have a 1mm, 1mm, 2mm ring pack, graphite coating on the skirts, and are a shelf-stocked piston. The block requires several gallery plugs. There are 16 for the oil passages only. Pay attention to your block instructions to make sure you get everything in where it's supposed to be. We've never been ones to stick to tradition when it comes to painting engine blocks. This may be the biggest departure yet. The engine's automatically going to make more torque, you know why? It's got to make big diesel torque if we paint it Duplicolor's Cummins beige. This color will also let a leak be found quickly if one does come up.
Since this is a purpose-built engine and we will be putting it through the ringer, we're not skimping on any of the parts. That includes the timing set. Instead of a chain like this, we will be running a Jessel belt drive. Now the benefits are more accurate cam and ignition timing, an increase in strength, and ease of adjustability. Here's a rundown of how the Jessel belt drive installs. First, a slim bead of the right stuff from Permatex will be applied to the block. Now the Jessel timing cover is installed. It houses a Teflon-coated high-vacuum crank seal. Belt drive setups do not use lubrication from the engine. A little more RTV is placed on the recessed area of the cam adapter. Engines with high vacuum can get by without the silicone. We're not running a vacuum pump, so this will prevent a leak. With a thin film of oil on the outer bronze thrust washer, it can be placed over the nose of the cam adapter. Now the Urson hydraulic roller camshaft is slid into the block. The cam tunnel is raised 134 thousandths and has a 55mm Babbitt cam bearing bore.
Here's a look at the cam card. We had this one custom ground directly from Urson. Now we need to determine the camshaft's end play. That requires placing all 3 thrust shims and a thrust plate in place. Now tighten a couple of nuts and check the end play. It should be between 8 and 12 thousandths.
To prevent oil leaking through the shim pack, a very thin film of silicone is put on them. This will add a little thickness, but as long as the end play is still in range, it's good to go. With the crank snout lubricated and a little more RTV silicone to prevent seepage, the pulley is tapped into place using a gear driver. Now the woodruff key is installed, along with the idler. The belt is routed around the lower pulley and to the inside of the idler. Then the upper pulley assembly is lined up with the timing marks. Finally, the cam adapter washer and 7/16 by 20 left-handed bolt can be torqued to 70 pound-feet. Keep in mind, engines with a big stroke crankshaft and a large cam core can have clearance issues. Turn the engine over by hand to make sure everything clears.
Up next, the Motown gets down with billet lifters, high-flowing heads, and a massive intake manifold. We're expecting good things on the dyno.
Welcome back. Before we go any further on our triple threat Camaro engine, we need to degree the cam. This lets us put the intake centerline exactly where we want it. In this case, it's installed 2 degrees advance at 112 degrees. Next is the Melling high volume oil pump. The pickup has been tack welded in place for extra insurance. It's always common practice to measure the pickup's distance from the pan rail to verify its clearance in the oil pan.
With that checking out right, a little bit of Right Stuff gasket maker is put in the corners to ward off any potential leaks. Then a one-piece steel reinforced rubber gasket is laid into place. Be sure to seal up the unused dipstick hole in the gasket. A little more gasket maker on the ends, and our Canton Road Race oil pan drops onto the block. It's fully trapdoored and baffled, and has an oil capacity of 8 quarts. It also features a built-in windage tray. To complement our Urson hydraulic roller cam, we have a set of Tie-Bar style Pro Race Series hydraulic roller lifters made from billet alloy steel. For fasteners, we always rely on ARP for all our projects because they perform beyond our highest expectations.
Royal Purple break-in oil lubes the rollers as they drop into position. These are 842 thousandths in diameter. More Right Stuff is put on the China rail, and the Valley adapter is bolted down. This makes way for installing our Cometic MLS head gaskets. The multi-layer steel design has a 4200 bore and a 30 thousandths compressed thickness. After lubing them with some ARP Ultra Torque, the studs are threaded into the block. In most cases, we put the studs in after the head is on to avoid getting aluminum on the threads. But because there are only 10 short studs, the heads can be installed carefully with the studs in place.
The TrickFlow Gen X 260 LS7 heads come next. They are torqued in 3 stages. First to 30 pound-feet, then 50 pound-feet for the second, and finally to 80 pound-feet. Next, an SFI-approved harmonic dampener from PowerBond slides on. It's safety rated to 12,500 RPM. A Matco balancer installer makes quick work of the job with no hammering required. An adjustable billet timing pointer which fits our 8-inch balancer bolts into the timing cover. With the cylinder head off, it's easy to set true TDC with an indicator and a piston stop.
We'll install the head for mock-up purposes with checker springs in the #1 cylinder. An adjustable push rod is utilized to measure for proper push rod length. To determine that length, the cam must be on its base circle. Then the push rod is extended until all the lash is taken out and there is no more clearance between the push rod cup and the end of the push rod. The push rod is carefully removed and measured for length. We will order a set of 7 900 push rods for the engine. The crown jewel to any well-designed induction system is the intake manifold. This is Edelbrock's Super Victor LS7 intake. Now this is 750 thousandths taller than their LS3 Super Victor and is set up for a massive 4500 series Dominator carburetor. Its operating range is from 3,500 to 8,500 RPM. And as far as horsepower is concerned, this manifold is capable of making over 800 horsepower in naturally aspirated form. With the intake on, this engine is really taking shape.
Up next, a couple of finishing touches and this engine's ready to rock.
Welcome back. We decided to paint these Holley Dominator valve covers the same Cummins beige as the block. Now we want to move on and show you a little more about the cylinder heads that are on this Motown LS. They're Trick-Flow's Gen X 260 for LS7 engines. The valve sizes are 200 on the intake and 600 on the exhaust. They have a 70cc combustion chamber that is CNC machined. The intake runner volume is 260 cc's and the exhaust measures in at 87. They come with dual pack valve springs and titanium retainers. They can only be used on LS engines with a 4/100 minimum bore diameter. Here's a look at the flow sheet directly from Trick-Flow. With numbers like these, this head will make power on any combination, even ours on pump gas and naturally aspirated. We expect to see numbers deep in the 600 range.
Our push rods arrived from Trend Performance. They are 7/900 in length with 105 thousandths wall thickness. They are 5/16 in diameter with a 5/16 ball on each end. And they are fully hardened for durability. Our valve train needs to be as durable as the rest of the engine, so we chose a Jessel shaft rocker system. With the stand bolted down, the heavy-duty 1.8 ratio rockers go on individually.
Lighting the air-fuel mix is a set of E3 Diamond Fire spark plugs. No gapping or indexing is required. Next, a set of MSD 8.5mm superconductor wires, which will hook up to our MSD Black Series billet distributor. It comes locked out with a bronze gear already installed from MSD. Efficiently mixing the air and fuel is a Holley XP 1050 Ultra Dominator. This is another one of our test carburetors that runs great on any engine we put it on.
To lubricate this stout bullet, we'll use 8 quarts of Royal Purple XPR in 5W30.
This is 6.
It's designed to handle high horsepower race applications. A Royal Purple oil filter finishes it out.
All right, everybody, we're in the lie detector chamber with our 440 cubic inch Motown LS. We've already ran it quite a bit, making sure the rings were seated and the carburetor is all dialed in. Now it's time for Pat to make some pulls and see what this thing will make.
And we're going to start by going at 24 degrees of total timing and making our sweeps from 3 to 6,000 at 400 RPM per second. That'll see if she keeps her guts in.
She's making some steam, brother. 624 on power, 546 on torque.
Now we're ready to make a pull from 4,500 to 7,000 RPM. Hold on to something, this is gonna be good.
Did you see the needle on the red gauge?
Let's see what comes up.
671, 557. 671 horse on 24 degrees of timing.
On 93 octane. That is absolutely incredible, and we're just getting started.
Tuning, baby.
Up next, we're pretty sure this engine's got a few more ponies in it, and we're gonna look for them.
Hey, we're back with the dyno session for our 440 triple thread engine. We've had a good, successful start so far, so now it's time to do a little bit of tuning, and we're gonna bump it up 2 degrees to 26. Fire it up, man.
674 with a 3 and 558 on torque.
Okay, that's not surprising because these heads are so good and the chamber is so good. Flat top piston, it's not gonna require a bunch of timing.
Yeah. But we might pick up a little power by swapping the jets. 2 sizes smaller on the front and back. .676, 561. It picked up 2 numbers.
It did pick up a little. Right there at 26, it just got to have a tiny bit of run on, which means it's that close to detonation.
Yep.
Let's mix up a little gas for it.
On the game. Just a few ounces per gallon of race gas fuel concentrate, and we're up to 98 octane. All right, Picked up 1.5, 677 with a 5, and 561 on torque.
That's pretty sporty. I even hate to say this, I don't think we have much more in it with the parts we have in it. If this were a more drag race oriented deal, a solid cam with a little bit more aggressive cam, because I mean, I'll be quite honest with you, I undershot the cam on it. and that it's easy to change with what the setup we have. We may still do that. This thing makes 1.54 per cube on pump gas, and then a little racy gas, it picked it up a little bit more. So awesome engine.
Win-win.
This is an awesome engine.
You know what's even better? It's going in the split bumper.
Yeah! For more information on anything you've seen today, go to PowerNationTV.com.
Today on Engine Power, the triple threat Camaro continues its transformation from a bone stock Chevy to a full-fledged high horsepower racer. But first, we have to strip it down to make room for a high performance chassis.
Today on Engine Power, Mike and I are getting back on our triple threat Camaro for this year's annual barbecue and burnouts competition. It's a 1973 split bumper model that was a well taken care of, one owner ride. It deserves a catchy nickname for several reasons. Big power, a killer chassis, and a ton of other safety and go fast parts make this a force to be reckoned with. It is now officially the Split Bumper Thumper.
We put the car on the back burner to build a healthy power plant for this triple threat contender. Now, it's what we consider a hybrid. From the deck down, it's all original small block Chevy parts, but from the deck up, it's packed full of killer LS induction. Here's a quick look at it making a power pole back on our Superflow dyno. This stout small block packs in 440 cubic inches. The compression ratio is 11.35 to 1, and it runs on 93 octane pump gas. We turned at 7,000 RPM, and we are excited about the results. 677 horsepower and 561 pound-feet of torque.
We have more teardown and prep work to handle before the new chassis can go under this body. The front fenders, core support, front clip, rear axle, and leaf springs all have to be removed. And for those of you just catching up on this build, Street Rod Garage built us a one-piece chassis to go under this soon-to-be G-Machine. It was built specifically for our triple threat theme, an engineered masterpiece designed to greatly improve handling, improve strength and rigidity, and most importantly, give the driver the feedback of the pavement to push it to its limits.
I got you something today.
What's that? Oh, thank you. You better mark where this goes, because I'm not going to know.
Today, the first things to come off are the front fenders. Look how solid the inside of these fenders are.
That's not bad for a 1973, huh?
That's unreal.
Look at that. Usually they're all rotted out and looking bad. This car is
Gotta love California for the cars.
so nice. Because every time I pull something off, a bunch of these hit the ground. See? See that right there? Don't scratch it, Pat.
The AC lines are removed, followed by the front clip mounts.
Oh,
Nice hustle.
look at that.
An easy, clean way to drain old brake fluid is by using a Matco fluid evacuator. It quickly clears the reservoir and brake lines without making a mess. Since we're running all new brake lines, we'll cut them near the firewall. Now we can go up, do the same thing on the fuel line on the back side of the front clip.
I do the important work.
With the subframe mounts unbolted and the steering shaft hammered out, the front subframe slides out easily. There we go. Now we will need to keep these, but everything else can go.
Perfect.
With that, the front end teardown is complete.
Up next, the Camaro gets ready for a high-tech fuel system that keeps the OEM appearance.
We're back on Engine Power, tearing down the back half of our triple threat Camaro. I don't know how much is in it.
I don't either. I'm kind of nervous, actually. There it goes. Okay. It doesn't sound like there's much in it. That's a plus. There you go. Nice. Just like that. We wanted to keep it simple as far as fitment for the fuel system on the Camaro, and Holley makes that easy with their Sniper EFI conversion fuel tank system. Now we are running a carburetor on our rig, but this will still work great for us, and the best part about it is it's a direct fit for our application. The tank is made out of galvanized steel and is also powder coated for the ultimate in corrosion resistance. It is also internally baffled and comes with a new fuel pump assembly, fuel sender, and filler neck. It even comes with new gas tank straps that makes this whole deal a bolt-in with zero mods and an OEM appearance, even though it's actually a high-tech engineered system. If this car was from Michigan, all this part right here to be actually gone. I had one, a Maverick, where the springs went over a bump and both leaves went through the trunk.
No way. Wow. To remove the rear end, we'll use a cutoff wheel on the leaf spring brackets, followed by an air chisel. With the emergency brake lines cut and the remaining leaf spring brackets removed, the rear end rolls right out.
Cool. Oh, glorious.
Our factory rear end with its leaf spring suspension is going away for good. In exchange is this killer Fab 9 housing with a steeper gear ratio, better differential, and axles we don't have to worry about braking. All connected to a fully adjustable 4-link suspension with coilovers. For more information on anything you've seen today, head over to PowerNationTV.com.
If it's getting bigger tires, it's gonna need tubs. Today on Engine Power, our split bumper thumper receives a set of tubs to make it wide tire ready, but still keep that factory look. Plus, a DIY roll cage for extra safety and structural stiffness. And fresh body mount bushings give us a smooth ride without sacrificing performance on the track.
Today on Engine Power, Pat and I are working on a project we call the Split Bumper Thumper. It's a 1973 Camaro we're turning into a triple threat contender. It's a car that's going to be able to handle the autocross, the road course, and the drag strip in stellar fashion. Now we want to keep all of you guys up to speed on the build, so here's a quick look at what we're working with so far. Last time you saw us working on this car, we removed the front clip.
Nice hustle.
Look at that.
The subframe, and fuel tank, plus the rear end and leaf springs. Preparation for this killer one-piece chassis built by Street Rod Garage. Big brakes, coilovers, and a fabricated 9-inch rear end are huge improvements over what we pulled out. The engine is unique. It's a 440-inch Motown LS. It uses a small block Chevy rotating assembly and LS induction. This engine makes awesome power on pump gas. Just look at the graph.
Today we're going to handle everything that needs to get done to mount the body to the chassis, and that includes wheel tubs for our larger rear tires, a roll cage that's specifically built for this 73 Camaro, and a ton of other stuff that will take this build to the next level. And it's all going to get started by having the wheel tubs swapped out.
For that, we need to remove some of the interior of the car, starting with the seats. Even though we're not reusing them, they will be taken care of due to the shape they are in. With a couple of bolts removed, the rear seat bottom and back come out.
Oh, I'm sure there's a bunch of $100 bills in here.
Well, wouldn't that be nice?
Because this was an LT model, it did come from the factory with additional insulation. We're getting rid of what is necessary to do our work. With everything out of the way, the surgery begins. Detroit Speed sends detailed instructions with templates to ensure you make the perfect cut. They even have photos so you always have a visual of the next step. It's a little time-consuming, but removing the inner tub is like removing a piece of a puzzle from the middle. Here's a compare of the stock inner tub and the new Detroit Speed one. It's a quality stamping that enlarges the wheel well so a larger tire can be ran. Here at the Power Nation Studios, there's a lot of give and take that goes on between the shops. Now, Pat and I build a lot of engines for the project vehicles down the hallway. Today, we're getting that favor repaid. Jeremy Weckman from XOR is coming down to help us install the driver's side wheel tub, and we get a little bit of a break today.
This car is so solid, I want to take my time and make sure that the new tub looks like it came from the factory. So using a spot weld cutter, I'm removing the seat back brace that connects the tub to the package tray. The front template is well made but needs to be positioned properly. Once in location, a cut line is traced on the floor itself. The same goes for the rear. Tape is ran from front to back, connecting the two template lines to ensure a straight cut.
So if you look real close, you can see the factory spot welds where they actually put the outer and inner wheel tub together in with the floor itself. So we're going to mark each one of these little spot welds, and then we'll use our spot weld cutter and we'll try to cut those out. That way we can save any of this just in case we need it later, because I'm not quite sure what we have to cut out yet. So we'll get rid of a bunch of those, and then we'll come back up and inside here and cut the actual inner tub out.
Once the spot welds are all separated, I'll use a slicer wheel to rough cut the old inner well out. Then just clean up the lip.
Coming up, Jeremy finishes up the tubs while Mike gives the roll cage a fabulous finish.
Welcome back to Engine Power. Today, Jeremy from the XOR shop stopped by to help us install the mini tubs on our triple threat split bumper thumper. So far, he's removed the stock tub, and now additional metal must be cut before welding in the new one.
With a variety of different tools, the long cut from the front to the back template is made. With the tub mocked up, we can mark the line for the new wheel well flanges.
So these two pieces are going to end up making the inner flange that the wheel tub's going to mount to. So we have to bend this to match the contour of what we just cut out for the rear and for the front here.
So it's only 1/8 inch plate steel, so we should be able to slowly manipulate. The good thing is you can always bend it back if you go a little far, so you can see how easily it bent. I'm gonna add a little bit to the end.
Now the rear is fit. We'll move on to the front. Get a base starting point. Actually follows the curvature of the floor here really well. With the flange tacked into place, a couple more trimming cuts are made. I'm using a pneumatic hole punch to recreate the factory spot welds. The Detroit Speed tub goes back into position for the last time and is burned in.
Well, Jay, I'm like a blister. I show up when all the hard work's done. Mike did that side and you did this one. Tell me about how it went in. It looks great. So.
Well, it actually wasn't that big of a deal. The way that I like to do it is trim to fit. So when you put your lines on where they want you to cut, I always cut a little bit of short of that. Make sure I can bring my line out where I need to as I fit the piece. So it went in pretty good. All the pieces that were made or that we had to bend, they all fit absolutely perfect, and it's all up and in there now.
Well, we really appreciate it, and man, we All we got to do is, I got the hard job now. I'm going to seam seal it and shoot some undercoating on it, and we're good to go. So, man, thanks very much. Appreciate it.
Anytime, I'll come down and do some welding.
Oh, you're going to have to if I'm involved.
Fantastic.
Here's a look at the finished work after we've seam sealed and undercoated it. Although we needed to make room for bigger tires, we wanted to keep an understated, almost factory look. The Detroit Speed tubs worked great.
Up next, an easy-to-install roll cage makes this race car stronger and safer.
The next step in our triple threat adventure involves installing a roll cage. A well-engineered cage has several duties. The first and most important is to keep the occupants of the vehicle safe. Second, it adds a lot of strength and rigidity to the chassis, whether it's a subframe or full-frame car.
And that allows the suspension to react more predictably to driver input for a better handling vehicle. And when the car is more predictable, the driver has more confidence, adding even more safety to the driving experience.
With all the tubing thoroughly cleaned and wiped down, it's time to mix some color. It's a durable black sealer that will give me a good base for what Pat and I have planned for a final color. Round tubing is difficult to spray. Making sure you get 100% coverage is key. All this received 3 coats in total. I'm getting in a suit for the next step, which is spraying the clear. We mixed it with quite a bit of pearl. The idea is to make the bars look wet at all times and make your eyes chase the radius of the pipe. What do you think?
With the paint dry, it's time to start the install. The Tiger cage comes with everything that you need to put it in, but don't be intimidated by the sheer number of parts you see here. The cage has been specifically engineered and designed for the DIY type of person. The Tiger clamps are made from cast stainless steel, and the fasteners are either grade 8 or stainless themselves. Per the instructions, these main hoop mounts are the first thing that are going to go in. We use the bracket as a template to drill the holes. With the bracket in place, grade 8 hardware and backing plates will secure it. Now the main hoop is passed into the car. It locates into the flanges of the previously installed brackets. Make sure to leave all the fasteners loose until the entire cage is installed. A Tiger clamp is attached to the main hoop and will be the anchor point for the bar that goes into the package tray. From inside the trunk, another tube intersects the package tray and goes to the trunk floors. These fasteners sandwich the package tray and the tubes together. Every location the cage attaches to the body, a sturdy backing plate is used. More Tiger clamps attach the road race style door bars to the main hoop. These door bars have a great profile for protection and ease of getting in and out of the car. The seatbelt bar is the final attachment.
Look at that. Fitment, fitment.
That's some engineering right there.
Yes, sir.
Okay, that is 21 right to the center line of the bar.
What did you say?
21.
Money. Couldn't be any more perfect.
Nice, nice, nice.
Very nice.
Good hustle.
Up next, the chassis and body are finally together, and we think you'll like how it looks.
We're back and have plenty of work left to do on Project Split Bumper Thumper. Now we went ahead and started getting the chassis ready to be mounted to the body. We had to do a little bit of cutting on the floor pans of the car. It was expected and not that much work. Check it out. I used a slicer wheel and a buzzsaw to remove the section. There's one on either side, and that's where the frame rail is going to recess up through the floor. Keep the cut as narrow as possible. It will keep the amount of work to cover the frame rail at a minimum. We need to replace the old distorted rubber body mount bushings, so we gave Summit Racing a call and they sent us this set from Energy Suspension. Now these are made from Energy's Hyperflex performance polyurethane that'll give you a nice smooth ride, but it's also rugged to handle the extreme abuse of the road and track. These bushings incorporate a steel ring that is molded in for added durability. Zinc-plated hardware is included, and one set will take care of the driver and passenger side of the car. The instruction sheet must be followed for proper bushing placement. Otherwise, the car may not sit even on the chassis.
They register in the brackets on the chassis. It's a snug fit and should be to eliminate the chance of the body moving around. That. Perfect.
Well, Pat, here it is. This is gonna be the first time the chassis and the body go up in the air together. Now it sits killer at this height, but I can't wait to see it up there.
I tell you what, for swapping out a stock subframe vehicle for a rigid chassis, it fit great and it was way easier than I thought it was gonna be.
Yeah, there wasn't that much involved. Just a couple cuts on the floor and she was good to go.
Let's get her up in the air.
Let's see it. Wow, that is nice.
Doesn't get any nicer than that, is right.
That is really nice. Look how
that
close.
All this fits. That is a well-engineered piece right there.
Everything's tucked nice.
When they're separate, you know, you're not gonna be able to tell like gaps here at the body,
right,
and things like that. This thing is nice.
You nailed it.
All his points, they line up. Little minor cutting, but that was to be expected to get it to set where it's supposed to.
Oh yeah, I mean look how close the chassis sits to the floor of the car everywhere. I know we recessed the frame rails in the two drops for the seat locations, but other than that, this is like, ride height's gonna be killer.
Yeah, that goes off the body mounts because this thing's engineered to work with all the body mount places, and he nailed it.
I like how we tied into the rear spring locations on the rear of the subframe to the chassis. I mean, this is just awesome.
We're that much closer.
Yes, we are. Well, now stuff's gonna start going pretty quick.
But the actual, for mock-up it looks great, but the whole thing has to come apart because it's easier to stick the engine and trans and get all our drive line up because we can literally just unbolt the body and do it and then drop it back on.
I gotta lift it back off once I get all my measurements to do the caps and stuff over those frame rails from in the floor, but that's not that. I'll start that next.
Oh no, this is
really nice.
This is spectacular. Very, very happy we did a split bumper.
This thing's gonna have a lot of power to it.
Yeah, oh yeah.
For more information on anything you've seen today, head on over to PowerNationTV.com.
There's more racing coming up, but for right now, we're getting back to work on the split bumper. With the chassis where it's supposed to be, we can now take a couple of measurements and build the caps that cover the exposed frame rails that are inside the vehicle.
All right, we're gonna bend the cap at 3 1/4 inches wide and drop it down through the floor about 3 1/2 inches. That way it'll let us trace the floor pan on the skirt of the cap, and we can cut that and it'll be the same shape as the floor pan. Let's go bend it up.
We borrowed some 18 gauge steel from Detroit Muscle's metal supply. We'll make our marks at 7 1/4 inches. Got it? This is the only thing I'm good for, ballast. The shear will ensure a perfect edge and a straight cut is made. Now mark the center of the piece on both ends. It is 3 1/2 inches. With the piece going into the brake, we bend it all the way to 90 degrees on both sides. Yep. Oh, that's lovely. Now the cap is cut to length on our new Trajan 125 bandsaw from sawblade.com. It'll cut all types of metal up to 5 inches. It also has a variable speed motor for a variety of cutting from angle iron to stainless steel. With the cap in place, the chassis rolls out again.
Just think, there's only maybe 1 or 2, possibly 2 more times we have to do this.
I know, I'm very excited about that.
Done. Now we're gonna make a line on the actual skirt of the metal piece that follows the floor pan. That way we can cut it when we pull it back out, and it'll be a very nice fit. Trimming the piece with ease is a Matco Infinium 18-volt power shear with a 4,500 RPM cutting speed. And cleaning up the areas the shear could not get to is a Matco die grinder with a 36 grit roll-lock pad. trimmed and back in, it's getting tacked in place. Wrapping this side up is a small patch at the very back of the cap. Underneath, it's sprayed with rubberized undercoating, and up top, a nice bead of seam sealer is used. Once it's dry, Duplicolor enamel in Cummins beige will protect anything from surface rust. Now that the caps over the frame rails are welded in and seam sealed, we can move on to the back area of the floor pan where the upper control arm mount comes through the floor. Now this may look a little boxy, but we're also going to use it as the foundation for the rear seat delete lower panel. Now we're going to go ahead and lay this thing in the floor, mark our radius of the floor pan, cut it out, then tack it all in.
I'll mark this outside.
Yep.
So that'll get your cut on this outside part.
Making sure the piece is level side to side and front to back will mark the radius of the floor pan.
Nice hustle.
Just like the other piece, a final touch-up will ensure a good fit. Now it's tacked in, going with half-inch spacing all the way around to avoid warpage. All right, now I'm going to use an empty bottle of argon to shape the actual plate that we're going to be putting in the car. Now the radius of the bottle is real close to exactly what we're looking for to cover up that box section we just put in. You want to make sure that the plate is straight with the bottle, so we'll use the painted line from the bottle company. Let's go take a look. The bend looks good, and with a mark made, we can cut it to length. This piece is tacked the same way. Finally, we need to make 2 side caps, and a quick mark is all we need to continue.
All right.
Now the nibbler will do that to the piece of metal, but it's an easy fix. Ready to go. More seam sealer is used here. Use a wet finger to smooth it all out. A little more Duplicolor for protection and a few shots of undercoating make this a finished job.
Up next, the triple threat Camaro receives a race-ready fuel cell.
Hope you enjoyed the racing action. Now it's time for us to move to the back of the car and start installing the fuel cell. Originally, we were going to put a stock style tank back in, but we need the real estate under the trunk pan for some other items.
The cell is a Summit Racing brand and has a 17-gallon capacity. It's constructed out of 5051 aircraft aluminum alloy for superior strength in a lightweight package. All of the seams are TIG welded, and it comes in a natural finish like this one, or you can even get it powder coated in red, black, or blue. Dash 8AN fittings are used on the pickup, return, and vent. And to work with a stock fuel gauge, we ordered this one with a 0 to 90 ohm GM sending unit. The vent also doubles as a safety feature. In the event of a rollover, there's a check ball that's inside that seals the fitting, preventing fuel spill.
The trunk pan is super strong and solid, so we're going to mount the cell directly to it. The only problem is there's no mounting tabs on the tank itself. So we made these out of some aluminum sheet, and all we need to do is TIG weld them on. They are TIG welded in place, making sure a large area of the tab overlays the tank. Each tab is prepped to ensure a good clean weld. Once laid in place, I'm preheating the thinner material, which is the tank, so we avoid any weld cracking.
Voltage is controlled via the foot pedal. Just don't weld the two together. Make sure to use filler rod to ensure a strong weld is achieved. Everywhere there is a joint, it's getting welded. We don't want any flex at these points. This top weld is the final bead for this tab. With all the tabs welded on, we can lay the cell in place and mark the holes that will be drilled. Using a Matco cordless drill and an 1/8" bit, a pilot is made at every mark. Then a unibit is used to open up the holes. ARP bolts are placed into the tabs, and underneath the trunk pan, large washers, lock washers, and the nuts are put in place. Finally, the tightening happens and our cell is locked in place. We've got a ton of work done on the split bumper thumper, but there's also a ton more to do. Like any other project of this magnitude, the devil's in the details.
Now this is a really big build and we appreciate how much you guys are following along. Keep it up. Now if you want to find any more information on the products we use in today's shows or the tools, log on to PowerNationTV.com.
Today on Engine Power, the triple threat Camaro's power plant goes home for good, where it gets an accessory drive designed for no-nonsense high performance at the track and on the street. Plus, with plenty of race-ready components under our Chevy, there's not much room left for something like a 3-inch dual exhaust. Lucky for us, MagnaFlow's own Richard Wadus is here to help.
Today on Engine Power, we're working on our triple threat Camaro. It's a 73 split bumper that is getting a full treatment of Go Fast parts. Now this week we have a guest in that is going to build a custom exhaust for this chassis. First things first, Pat and I need to get the engine and transmission dropped in for good. Then that exhaust work can begin.
Using our engine hoist, we will carefully lower the engine and trans as an assembly into the chassis.
All right, start walking her in. All right, you're against it now. Go ahead and start coming down real easy.
Okay. Look at that. Okay, beautiful. Once positioned, ARP fasteners are used to secure it. Level 10 Transmissions built us this TH400 out of the best parts that they could get their hands on. It starts out with an aftermarket Super Hydra 400 transmission case from Reed Racing. Inside is a reverse pattern manual valve body, roller tail bearing, large planetary gear carriers, and an improved billet steel pressure plate. The bell housing is removable so the trans can be used with several different popular engine combinations. And inside, an SFI flex plate and billet converter wrap it all up. Level 10 has been in business for 46 years and they build both domestic and import units.
There is a missing link in the driveline right now, and it's just as important as the engine and transmission. Without it, the Camaro just won't move. It has to be straight, balanced, and it has to handle an exceptional load of torsional stress. It is the drive shaft, and ordering one takes specific steps that have to be followed. You don't want to order a shaft and just hope it fits. Having one lengthened or shortened can be a pricey ordeal.
Now, each company has their own specific way for measuring for a drive shaft, so be sure to use the order sheet from that company. We're going to be ordering up a carbon fiber 1350 drive shaft from QA1. We went on their website and printed out their instruction sheet, and we'll be following it to a T to ensure that we have a drive shaft that fits right the first time.
Before we make any measurements, we'll fill out some basic info on our vehicle, such as the engine and transmission specs, tire size, and gear ratio. The first measurement requires a slip yoke to be placed in the back of the transmission. This is just a mock-up piece for us, and we want it spaced out about 1 inch from the tail housing. That way it has the travel it needs when the shaft is installed for good. All right, Pat, this measurement is basically going to be center of U-joint cups to center U-joint cups on the back. On the face?
Yep.
All right, so we've got 48 and 11/16. All right, now we got to measure from the back of the tail housing to the same face on the yoke.
Okay.
51 and 5/8 on the money. The final measurement is from the end of the output shaft to the end of the transmission tail housing. Now we have all the measurements we need to order our drive shaft. If you need any help with the actual measurements, just look at the visuals and they'll show you where to measure from. All we need to do now is fax this over to QA1 and we'll have our shaft in a couple weeks. The drive shaft we're ordering from QA1 is a carbon fiber shaft. Now QA1 CNC machines their billet yokes specifically for the 11-step bonding process to adhere them to the drive shaft itself. They make a couple of different levels of the shafts as well, so let's check them out. What we would call an entry-level shaft, but it's still a custom shaft from QA1, is their 2 1/4 Rev Series. Now this comes with 1310 series U-joints and is available for vehicles with a max rated power of 750 horsepower and 500 pound-feet of torque. They retail for right at $820. The shaft we're ordering is their custom 3.2-inch Rev Series. Now these come with 1350 series U-joints and are capable to handle 2,000 horsepower and 1,500 pound-feet of torque. You can order them up to 65 inches long and they start out at $1,295. Now that the shaft is ordered, Pat and I are going to get the chassis back underneath the body for the next phase of this project. We'll be right back.
Up next, our vintage Camaro receives a dual exhaust with lots of late model appeal.
Welcome back. We just wrapped up getting the engine and trans placed in the awesome Street Rod Garage chassis. With the body back in place, it's time to tackle another big job when putting a car together, the exhaust. For that, Richard Wadis from Magnaflow is here to work his talented hands on a 3-inch system for this triple threat car using Magnaflow's custom builder kit. Richard, we see you floating around quite a bit all around the country putting exhaust systems on top-notch cars, SEMA vehicles like that. What does that do for you?
Well, I got into this business because I was an enthusiast first, so I'm really following my passion, but don't tell my boss, I'd probably do this for free anyways. But at the end of the day, there's a lot of value in seeing what pretty much the leaders of our industry are doing on their forefront as they're building it, and then ingesting all that marketing data as well to really understand what people are doing, where they're going, and kind of where technology is taking us.
Now you offer several builder kits, and what sizes do they come in?
We offer the builder kit in 2 1/4, 2 1/2, and 3-inch, all in duals.
Now we talked about, for this particular car, because we told you about the power level and what it's going to do when we chose 3-inch. Could you tell me why?
Well, optimally at 3-inch, usually with you guys, we're talking about peak power, engine dyno. We want to maximize the power. But here we're putting in an application that's got to be road race, drag race, and street legal. And we're running pump gas and everything. So we wanted a situation where we had a comfortable sounding exhaust that sounded good, but wasn't a major impedance upon the performance of the vehicle. So 3-inch, I think, was a good compromise from a sound quality to horsepower.
How are you going to design this system?
This is a pretty traditional setup in the sense that you guys got a long tube header, so it gives me a good starting point. 3-inch collectors, work my way back through the kind of the frame rails in there, get to an X, work my way to the rear section. And this car, there's not a lot of room for the mufflers with that chassis, so we're going to go over the axle first and place the mufflers in the rear, which is actually more like the modern, LS and Mustang type vehicles where we have that muffler at the rearward position, and then we'll do a turn down there. But we should have no problem getting the 3-inch through. We'll just have to determine whether or not the ground likes to touch it.
Gotcha.
Well, now we're happy you're here, and we appreciate all you've talked about. And now the easy part for you, the hard part for us, and that's why you're here, getting it done.
Let's go do it.
Like Richard stated, the header collector is his starting point. From there, the first Magnaflow 3-inch section is held in place to get an idea of where he will make his first cut. Mockup is the most important part of building the exhaust system. It allows you to make sure the pipes have adequate clearance of the chassis and other components on the vehicle. The X crossover is basically the intersection of the exhaust system. It needs to be parallel with the chassis because a minor alignment error here will be a major one at the rear. V-band clamps are used at the major connection points, like these that will connect the header collectors to the first pipes. Richard will be TIG welding the entire setup.
Tucking the exhaust as high as possible is the plan. Due to the limited space between the chassis and the body, we will be going on the bottom side of the chassis. Look at that. Richard is making sure this cut was the right length. He wants both sides to be mirrored images of each other. Here is a section that gets a little more technical. Making sure the bends are angled and cut to exact length is the trick to keeping the X crossover straight and in line with the chassis. Here's the result of skill and great craftsmanship in the first part of the system.
Up next, just a couple of tight turns and the Camaro will have a killer exhaust.
We're back and Richard is powering through this custom-built exhaust. Next up is from the X crossover to the rear. Like the front half, there's plenty of mock-up back here as well. The most difficult section is going over the rear axle assembly. It's very tight, which will require multiple bends and angles. Before anything else happens, Richard needs to get a visual of how the mufflers will be positioned.
Turned out to be dramatic, whereas this way,
you may have noticed there's no sparks flying when Richard is welding. Everything is TIG welded. It's a time-consuming and technical process, but the trade-off is having some of the nicest welds you can get.
The final V-band clamps are installed on the pipe just before going over the rear axle. This is a must, so the system can be separated and removed without any cutting. With the assembly back in place, Richard is fabbing up the hangers for the mid-pipe. They will go through the chassis and are dampened with isolators from MagnaFlow's kit. Here's a sneak peek on how both mufflers look in position. With this mark and cut, Richard now has the over-the-axle pipe on its way to being finished. What's not finished is the exhaust on Truck Tech's K5 Blazer, so LT came over to pirate our help.
Hey Richard, how's it going?
Hey LT, how you doing?
Doing good, good to see you. So what you doing here?
Full custom frame on a subframe vehicle, so pretty much everything from front to back's 100% custom.
Well, I like what you did here, you know, putting the mufflers at the back. That's kind of like a late model touch, I guess.
Yeah, a rear mount, simply no room up front, so with the gas tank in the trunk, we got a lot of space back here.
Since you're here, and since it looks like you're doing pretty good progress here, I got an exhaust system that we need a little bit of help on, so maybe do 2 this week?
I'm running a little ahead of schedule, so maybe jump over there, take a look at it a little bit later and see what we can fit.
Swing on by when you're done. Thanks, man.
Take care.
Now the mufflers are positioned and attached to the over-the-axle pipes. Here's a cool feature about the inside of them.
You'll find that a lot of the mufflers, they have a very dense sound to them. They don't sound hollow because that material is actually very densely packed inside. And we use a 2-stage, which is stainless steel on the inside of a basalt, which is rock wool.
Wrapping up the system are some handmade turndowns.
All right, Pat, just wanted to get your opinion here. We're just about wrapped up, and I can either do the tip with a little bit of an angle out and trim down, but if you think you need some more room, I've cut it so that it's a more radical 90 there. We could obviously trim it to the body line, but it gives you some more clearance. Just wanted to see which way you wanted to go.
I actually kind of like it if it's the first way. You know, like that to me, it looks, I like the look of that. The final welds are the hangers to the muffler bodies. Well, Richard, it was a pleasure watching you work and seeing what it takes to build a true custom exhaust, and you knocked it out of the park on this one. Thanks for coming in.
Always a pleasure coming down here, obviously seeing all the projects you have going, and of course, what new obstacles you're going to put out in front of me. All this stuff kind of makes sure that I keep my skills honed.
Yes, and I'm sure we'll have you back in the future because we're going to be doing more crazy stuff, so thank you very much for coming in.
Up next, a compact but capable accessory drive gives us everything we need for carving the corners at the racetrack.
We still have a little more time to get some more work done, so we're going to go ahead and move on to the next item in our checklist, which is the fuel system. Now normally we would run an electric pump on a car like this, but that's not the case this time. We're going to run this mechanical block-mounted pump from Holley that flows 200 gallons per hour. This is the Ultra HP Billet series that's made out of 6061 T6 aluminum. With the pushrod and mounting plate in place, the pump bolts directly to the block and is secured with ARP fasteners. A supplied -10 fitting goes into the inlet side and a -8 in the outlet side. A centered bronze breather vent goes in the top of the pump's housing. It is supplied by Holley.
Now we can mount the fuel regulator. This is Holley's 4-port VR Series 4 carburetors. It's adjustable from 4 to 9 PSI and also has a 1-to-1 boost reference if needed. It's compatible with gasoline, methanol, and E85. We're mounting it to this Holley billet bracket that attaches to the carb studs. We added a little fabbed bracket so the return fitting clears the valve cover. You may have noticed we have a completely different intake and carb setup on our 440. Well, that was by necessity. We knew we were going to run into some clearance problems with our new hood setup that you're going to see. So we decided to pick up from Summit Racing a Chevrolet Performance single plane LS7 intake manifold.
While Pat's getting some lines made up for the fuel system, I'm going to go ahead and get the accessory drive mounted to the front of the block. Now keep in mind, this may look a little funny and bare, and that's all because we're running a manual steering rack, so there's not going to be any need for a power steering pump. We're also going to leave the AC compressor out of the equation for now. What we will be using is this trick little setup from Jones Racing Products. Now they make front drives for the street, the strip, and circle track. Now they're lightweight, reduce harmonics, and definitely save horsepower. This one utilizes an Edelbrock water pump, so you know the longevity is here for the whole setup. Attached to the pump by billet brackets and spacers is a mini high-amp alternator from Jones Racing.
Installation is a snap due to the superior engineering of this product. First, the water pump and alternator bracket are installed using all grade 8 fasteners that came with the kit. Now the high-amp alternator is put in place, along with the bracket that attaches to the cylinder head. The billet aluminum mandrel is keyed to the balancer to prevent rotation. A belt retainer and a keyed lower pulley to drive the water pump are slid onto the mandrel. Now the water pump belt, alternator belt, and pulley are positioned.
It should be noted these are round tooth cog style belts which greatly reduce friction and are not designed to be ran banjo string tight. With it installed, the final results are a clean and very efficient belt drive system. For more info on today's products or show in general, check out PowerNationTV.com. We're making great progress on old triple threat. The entire fuel system is wrapped up and the engine's reverse cooling lines are attached to the thermostat housing Pat mounted on the driver's side cylinder head. I'm headed under the dash and this guy right here will tell you why.
It's pretty simple. We're going to take and replace the stock Camaro steering column with this Flaming River 33-inch muscle car floor shift column with tilt. Now this is a direct fit from 70 to 78 Camaros and Firebirds, and complementing that is this 13.5-inch D-shaped steering wheel. It's designed for maximum clearance on the driver, and the nice thing is it's wrapped in genuine Italian leather.
Removing the steering column is a no-brainer. It will take you about 30 minutes with the proper tools in hand. Being a direct replacement, the new column will bolt right in. It even accepts the factory wiring connector for all the functions it takes care of. To mate the waterfall wheel to the column, we have to use an adapter. Now make sure when ordering that the shaft diameter and the spline count are correct. The first thing we're going to do here is get the canceling cam installed. Now we want to make sure it works properly so the horn does not blow when you're turning the wheel. First, this aluminum spacer will slide on the column shaft. Then the canceling cam spring goes on. Now the canceling cam is slid over the shaft spring and spacer. The last piece before the adapter is a short aluminum spacer. For proper operation, Flamin' River wants the stem of the canceling cam between the 10 and 11 o'clock position as the adapter is put on the shaft. Now we're going to go ahead and put the steering wheel on just so we can torque the center nut on the steering shaft. We'll have to pull the wheel back off to get the horn button and the trim ring in for good.
Got the Gorilla Grip on her here. Here we go. Good hustle. Since our new fuel cell takes up the majority of the real estate in the trunk, we're going to be mounting the battery on the inside of the car on the floorboard of the passenger side rear, and we'll be putting it in a Taylor aluminum battery box. Now, this is a 3-piece design that's made out of 40 thousandths thick aluminum, and it complies with all NHRA regulations. And we also ordered a 2-gauge battery cable kit that comes with the hold down and the hardware necessary for the install. Because our back floor is uneven, I had Mike weld on some 1x1 aluminum so I can get her level. Gorgeous. For more information on anything that you've seen on today's show, log on to PowerNationTV.com. Our triple threat Camaro has been a fun project, and looking back, it's made a bunch of memories for us. About a year ago, we saw an online ad for it from a guy in Louisville that was trying to sell it, so we made the trip, and it was well worth it. As soon as we laid eyes on this car, we knew it was coming back to the Engine Power shop. That's when the work started. Big things were removed, like the entire front subframe, the rear leaf springs and axle assembly, some of the interior, all making way for trick new parts, like this SRG Force chassis from Street Rod Garage, a one-piece design that eliminates the stock front subframe and rear leaf spring suspension. We had it powder coated at Mr. Speed Coatings, then brought it back to the shop where the new marriage happened.
With all those killer parts, we had to build a stout power plant, and that's exactly what we did. It's a World Products Motown 2 LS. Now this thing is all small block Chevy from the deck down, and up top we mounted a set of Trick Flow Gen X 260 LS7 heads. Yes, you heard it right. This setup accepts all LS induction, so it gives us the best of both worlds, strength down low and flow numbers up top.
Today we need to get the shifter installed, mount the seats, finish up the steering, and wrap up some other small odds and ends. And the first thing we're going to tackle is this shifter. It's a B&M Pro Ratchet pistol grip shifter, and it has an IHRA and NHRA approved lockout that only requires one hand to operate. Its positive ratcheting action only allows you to shift one gear at a time, guaranteeing that you do not miss a shift. It comes with a neutral safety switch, a backup light switch, a black aluminum cover, and a CNC'd pistol grip. The 5-foot cable attaches it to the transmission. Look at that, engine guy doing shifter work. Lucky for us, the stock shifter cable boot is in the correct location for our shifter. Solid. And now the real test to see if the console still fits like it should. And it does. Now all we have to do is make a plate that covers up the hole in the shifter, and we'll do that a little later. To turn over our 440 cubic inch small block, we gave Pertronics a call, and they sent us one of their Contour series starters. This is a fully enclosed design that protects the solenoid and other key components from heat and the elements. It's very compact and can be clocked to clear different header designs. It's made out of all new parts and has a 4.4 to 1 gear ratio that puts out over 200 pound-feet of torque. It's available for different engine combinations and is even designed to start high compression bullets. And a few bolts back in the stock locations, and we have a slick install. One of the most important things to check when installing any aftermarket cable shifter is its function. They give you a bunch of different brackets because the shifter fits a multitude of transmissions. So here's a way to check to make sure it's adjusted correctly. With the shifter ratcheted to its full rear position, which on this transmission is high gear, we'll check the engagement of our gear selector, and it should be free and be able to slip in and out with no problem. Ratcheting up one gear puts us in second, and again, the puck should move freely in and out of the gear selector. Ratcheting up one more is low gear. Same thing. We want there to be no binding in any gear. Everything looks great in neutral. Reverse. And finally in park. Now all we need is a cotter pin to hold the cable in place.
Up next, two words that make anything better: carbon fiber.
We're back, and it's time to run the negative and positive cables from the battery to the chassis and the starter. First up is passing the cables through the holes I drilled in the floor pan. There are rubber grommets to avoid any damage to the cable. If the positive cable rubs through to metal, you are going to have a Roman candle on board. The ground cable is going to the chassis. A hole is drilled through this plate, Then a small area is cleaned to bare metal to promote a good ground contact. The positive will route towards the front of the car, securing it with cushion clamps at different locations. To keep it away from the flex plate and exhaust, this clamp was installed to position the cable in a safe spot. Now the terminal is fastened to the end of the cable and it attaches to the large starter post. I am also installing a ground from the engine block to the chassis. This is a must for a properly grounded vehicle. One end goes directly to the block, the other to the chassis, just like the battery ground.
The neutral safety switch is an important safety feature of any vehicle because it prevents it from starting in either forward or reverse. Here's a look at how the system works. It all starts with the ignition switch. A hot lead goes down to one side of the neutral safety switch, which in our case is on our B&M shifter. The other side has a lead that goes directly to the starter solenoid. This is the trigger wire that sends a positive signal so the starter can turn over. Now the shifter's position is what actuates this switch, so it has to be in either park or neutral for it to fire if this is wired up properly.
The original neutral safety switch wires in the harness are purple. Now these two heavy red leads are tied into those and will go to the neutral safety switch on the shifter. This green and pink set of wires is for the reverse light switch that was originally mounted down on the steering column. Now these wires are tied into the factory harness and will come to the piggyback switch underneath the neutral safety one. Installing the female spade connectors allows the wires to attach to the neutral safety switch that is on the bottom and the reverse light switch on the top. We just received a piece of the car building puzzle we've been waiting on for a couple of weeks. It's just as important as the engine, the transmission, and the rear end, because without it, none of those parts can be linked together. Now, it was a custom order piece from QA1 that we spec'd out based on several measurements and some pretty specific factors. QA1 has an order form you can print from their website that guides you through all the measurements you will have to supply them. Measuring needs to be done with 2 people. Make sure the tape is pulled tight and the measurements are taken to within a 1/16 of an inch. Fill in the sheet as you go. Make sure to double check your measurements. Carbon shafts cannot be shortened, and I guarantee you, you won't get a second one built for free.
We filled our sheet out and had this 3-inch 200 diameter custom Rev Series carbon shaft made for the Camaro. Now these are wound in-house at QA1 using 3M matrix resin that's specifically designed for performance use. The yokes are a precision CNC machine forged piece specifically developed for QA1's 11-step bonding procedure. 1350 high-strength alloy U-joints are used for maximum performance. The shaft is harmonic tested, precision balanced to ensure smooth vibration-free operation, and it is torsion tested. It is serialized before it leaves, and SFI certification is optional. We got ours with a 43.1 rating. This shaft will handle 2,000 horsepower and 1,500 pound-feet of torque.
If you can't stand the heat, get a better cooling system. Today on Engine Power, our triple threat Camaro gets a good case of frostbite.
Welcome to Engine Power. Today we're back on our Split-Bumper Camaro project. And for those of you who are not familiar with it, it is a 1973 Split-Bumper LT model. It originally came with a 350 small block and turbo 350 transmission, and quite a few things have changed since we picked up the car, so take a look. Mike and I took a quick drive up to Louisville, Kentucky to lay eyes on one of the cleanest, all-original Camaros we've ever seen. The car grew up in Southern California, where the humidity is low and the sun always shines, which keeps these old jewels in awesome shape. We brought it back to the shop and started the teardown by removing the front clip, then the subframe. Out back, the factory rear end and leaf springs came out, and we took another little trip.
To start the build of a one-piece chassis at Street Rod Garage in Grant, Alabama. Now they built it with tons of options to suit our style and ideas we had for the car. The fabrication that goes into these chassis is second to none. All the pieces are cut, placed in jigs, and welded in-house. The only thing we had to take care of was the powder coating. It was done at Mr. Speed Coatings in a gorgeous silver with a clear coat to give it tons of depth. The body received some modifications as well, including mini tubs out back. Then the chassis and the body were mated together, and the 440-inch Motown LS made a serious statement up front.
Now we're going to get the front end and core support mounted so we can get this car buttoned up. We did replace all of the old body mount bushings with new energy suspension urethane ones. The core support will get the same treatment. They are direct replacements that come with new sleeves and washers. Anytime you replace body bushings, make sure to do the core support. Otherwise, the front clip alignment may be sacrificed.
I don't want to knock you in the head.
That's okay. Wouldn't do any damage. Okay, go ahead.
Are your fingers bigger or smaller than mine?
They're less nimble. Is that a technical term? All right, I'm good.
All right. We'll leave these loose until we get the fenders and everything hung, and then we can start moving, tightening our gaps, and tightening stuff up from the front to the back.
All right, slide these in. Oh, I got it.
High horsepower street cars and trucks can be a challenge to keep cool. Now, the radiator is arguably the most important part of the whole cooling equation. Aluminum radiators typically cool better and are lightweight. Now, Holley Performance Groups just added another brand to their huge lineup, and it all has to do with keeping a car cool, and it's called Frostbite. This is Frostbite's 1970 through 81 Camaro and Firebird LS swap radiator. It's 100% TIG welded and has an aircraft quality aluminum core, fittings, and tanks for a 30% weight savings. The dual pass cross flow design maximizes cooling efficiency, and it has 3 rows to support 600 plus horsepower. Frostbite radiators are available for GM, Ford, Dodge, and Jeep vehicles. We're using the factory hold down to lock it in place.
Here is a new product that we are hyped about using on the Camaro. It is Autoplum's -20 water neck conversion adapter. It allows you to go from a standard water outlet to a -20 line for cooling. They work on radiators, water pumps, and water necks, and they are guaranteed to be leak-proof, removable, and resealable. Here's a look at how they work. First, place the assembly tape onto the adapter ring in a clockwise direction, then slide it onto the water neck. Place a small amount of grease on the shim and put it on the water neck. Now place a thin film of silicone over the entire seal and slide it over the water neck with the chamfer pointed towards the water neck's opening. Smooth the silicone out over the end of the seal and place a small amount of grease on the adapter body threads and thread it onto the ring. Now all you have to do when this is on the vehicle is grab it with the strap wrench around here and tighten it with your -20 wrench. And I must say, this is one of the slickest things that's come down the pike in a long time. This is a good look at how the fitting looks installed on the radiator. With the thermostat installed, the Autoplum housing bolts onto our remote inlet. Finally, the Earl's Performance plumbing fittings and the -20 hose can be attached.
We're back and wrapping up the cooling system with this steam vent crossover from TrickFlow. Its job is to allow air pockets to escape from the front water jacket in the heads to avoid steam pockets, which is a hot spot. The factory fan shroud is being reused. It attaches to the core support in the stock location. The fan we're using is an 18-inch Flexolite we ordered from Summit Racing. A Jones Racing fan spacer will get it correctly positioned in the fan shroud. For ease of alignment, I'm using ARP studs to secure the spacer and the fan. The core support is leaning forward, but once the fenders are installed, the fan will be inside the shroud. With the corner carving theme our Camaro has, we needed a set of seats designed to keep our backsides in place. For that, we ordered the most affordable FIA-approved racing seats that money can buy. The quality is not sacrificed. These are Corbeau Forza Sports, which are a fixed back design. Unlike other FIA-approved seats, these can be mounted in either a side mount or bottom mount configuration. Energy-absorbing foam is used, and they work with 3, 4, 5, and 6-point safety harness setups. They're designed for people with a 38-inch waist or smaller. On the bottom is a mounting bracket we ordered separately. Lucky for us, it is to mount these seats into a 70 through 81 Camaro, so this will be a 100% bolt-in setup. The RideTech safety harnesses need to be finished first. The lap belts will bolt directly to the original seatbelt locations. They are reinforced areas on the floor pan. The shoulder belts will attach to the harness bar. Make sure the strap is double threaded to avoid loosening at the mounting point. Now the new seats are going in. The brackets were spot on. I'm using ARP fasteners to secure it to the factory locations in the floor pan. Next, the belts can be passed through the seats, which is the final step to keep us in place on the track. When you break out the grease gun, you might as well grab a rag because it's gonna get dirty. And keeping the coupler on the Zerk fitting while pumping the grease gun can be a juggling act, but not anymore. This lock and lube grease coupler has a unique sliding sleeve and thumb lever allowing you to lock it in place. Once locked, no hands are needed to hold it on the Zerk. It won't leak either thanks to a locking jaw and seal. When you are done greasing, simply push the lever, remove it from the Zerk, and you are done. For more information on any of the products we used in today's show, log on to PowerNationTV.com.
Today on Engine Power, the triple threat Camaro gets a double shot of carbon fiber, including a top-notch drive shaft and updated styling cues.
Welcome to Engine Power. Today we are on the final stretch of a project that has transformed our bone stock 73 split bumper Camaro into a triple threat machine. Now this car will be able to carve the tight corners out on the autocross tracks, be wicked fast out on the road course, and even lay down a respectable ET out on the drag strip.
Handling, acceleration, and braking are all areas we've drastically improved upon, and we've used parts from the best manufacturers in the industry, and that is all a recipe for a good running machine. But at this point in the build, we need to do a quick recap to get everyone up to speed on where we're going to start today. When we say bone stock, that is exactly how we bought this car. It was a survivor that lived most of its life in Southern California. From the body to the interior, this car is in excellent condition. We removed the entire drivetrain because there was no intention of reusing any of it, and here's why. We had the guys at Street Rod Garage build us a one-piece chassis for this car. It was equipped with coilovers, big brakes, a fabricated 9-inch rear, and a super nice 4-link setup. The 440-inch Motown LS was built in-house and cranked out 677 horsepower. The exhaust was custom built by the one and only Richard Wadis from Magnaflow. Keeping the engine temperature in check is a frostbite radiator from Howe.
Today we need to get the rest of the body panels installed, mount the trans cooler, slip in the drive shaft, and mount a bunch of exterior body parts from Anvil. Now all of it's going to happen, but not necessarily in that order. Let's get started. We're going to get the drive shaft in first. It's a 3.2-inch custom Rev Series carbon fiber shaft from QA1. They are wound in-house using a 3M matrix resin. The forged yokes are CNC machines specifically developed for an 11-step bonding procedure. 1350 high-strength U-joints are used for maximum strength, and the shafts are precision balanced and torsion tested for vibration-free operation. We ordered this one with a 43.1 SFI rating. This shaft will handle the extreme loads of a 2,000 horsepower engine. It's lightweight and will definitely add some eye appeal under the car.
A transmission does have an enemy. It's heat. Hot transmission fluid can break down and lose some of its lubrication properties, and there are also parts inside the transmission that can't handle the heat either and will fail. Now, when towing, or in our case, high performance driving, the temperature in the transmission raises dramatically. So to keep that temp in check, a cooler is needed. This is Earl's Performance Plumbing Temp Accure Transmission Cooler. It has a 34-row cooler core and is made from aluminum for the fastest possible heat transfer. It has a -10 O-ring inlet and outlet, large volume collector tanks, and a superior stacked plate design that allows this cooler to have the equivalent cooling of one twice its size in a traditional tube and fin style cooler. Installation is a breeze.
Got her.
Up top, the cooler bolts to the core support. Heavy-duty mounting ties take care of the lower end. With Earl's AN fittings installed on their UltraFlex hose, they are connected to the trans cooler and the transmission. Once the fenders are in place and lined up, they're bolted up for good. This Camaro is looking great, and it's about to look even better.
Up next, it's classy with a touch of modern. The triple threat Camaro receives a carbon fiber hood and more.
From the get-go, the triple threat Camaro was designed to take a classic Chevrolet and give it plenty of modern performance while still respecting its heritage. We've got some new components that will suit that theme nicely. Anvil Auto manufactures a complete line of high-quality parts for American muscle cars. Using carbon fiber, fiberglass, stainless steel fasteners, and billet aluminum brackets, the Gen 2 Camaro components give our ride 21st century styling that complements the vintage look of our '73 split bumper. The matte finish on the carbon fiber looks great. The centerpiece to our updated body panels is this power bulge hood, and at 20.5 pounds, it's a real featherweight, over 40 pounds lighter than our stock steel hood. And it comes with some other features, like 2.5 inches more clearance than a flat OEM hood. It's made from 100% carbon fiber and comes in either a glossy or matte finish. And we chose the glossy finish because we wanted the front end of our car to pop. The bullet side view mirrors go together easily. They are made to fit the Gen 2 Camaro, but with a little light sanding, they will fit other generations of Camaros as well. Once the included bracket is bolted to the door, the mirror housing drops into position. A retaining screw keeps everything in place. Up front, the bumperettes use factory brackets for easy installation. To install the spoiler, some bolt holes are drilled into the trunk lid. Then the spoiler drops into place and is cinched up with ARP hardware. When installing body pieces like these, there's an easy way to mark the drill locations. Place a dab of grease on the bolts and press the piece gently against the vehicle. Then use the grease marks as a guide for drilling. We'll have to do a little work to get this hood installed, but for now, we're just checking for fitment and looks. Right off the bat, everything is lining up well. If you're looking for a tire in the ultra high performance category and want maximum grip in both dry and wet conditions, then the General G-Max RS will fit the bill. And it has some great features like smart grip technology with a strong center rib and stable shoulder blocks, Stability tread technology with an optimized footprint and 35% longer tread life than its competitors, and smart monitor technology that when the tread wear gets down to 230 seconds of depth, an indicator appears that actually says replace tire. Last but certainly not least, they come with a 50,000-mile limited tread wear warranty. But since our Camaro will spend the majority of its time on some sort of racetrack, we opted to go with these Hoosier Sport Car DOT radials. This is essentially a competition racing slick with a few hash-style grooves in them, and they provide the ultimate in grip on hot, dry racing conditions, and they come in a couple of different compounds. The R compound, which we are using, is designed specifically for road racing, and there's also an A compound, which was designed for autocrossing. The sizes: 335/30 ZR18s in the back and 255/35 ZR18s in the front. They are mounted on a set of custom-built American Racing VN430 series wheels we picked up from Vintage Wheels Incorporated out of San Diego. They are a strong two-piece design, and the sizes are 18x9s in the front and 18x12s in the back. We still have a little bit to go to get our triple threat car on the road, and until then, we are going to protect it with a new Covercraft Form Fit car cover. This is a Covercraft exclusive, and it's their most luxurious indoor car cover. It's made with polyester knit with spandex added to the yarns and special stretch fabric that allows it to form to the vehicle's contours. Inside is 100% cotton sheared to a fleece finish. It's covered by a 4-year warranty, and it is available in 6 colors. It's super soft, highly breathable, and offers ding and dent protection. Best of all, it's machine washable, so this cover can be maintained in most front-load washer and dryers. They even added the engine power logo to ours.
It's what every gearhead loves, taking your newest project out for a little shakedown run. Today on Engine Power, Pat heats up the tires on the triple threat Camaro with a little help from a mysterious man in black.
Welcome to Engine Power. This 73 Split-Bumper Camaro has been one of the most ambitious projects we have ever taken on. The goal was to create a race car that was equally at home on the drag strip, autocross track, or even the road course.
In a few minutes, this second gen is going on a pretty wild shakedown run. But first, let us show you how we transformed it from a stock, underpowered Camaro into a full-fledged race car. We got a lead on a Camaro for sale in excellent condition. And since we're not paint and body guys, it was worth hunting down a solid foundation to start the build. We headed to Louisville, Kentucky and found just what we needed. It's rare to find a vintage car to exceed our expectations, but this split bumper was immaculate. No evidence of rust or bodywork anywhere. Before the seller could change his mind, we loaded it up and hit the road.
From the factory, the Camaro had a subframe setup with rear leaf springs. But for our purposes, we needed something more. Another road trip was in order, this time to Grant, Alabama, home of Street Rod Garage. Co-owner Chris Sutton shared his plan to put a full frame under our rig, loaded with the latest and high-performance suspension. Chris designed the chassis using measurements from a second-gen Camaro he purchased himself. Once the design is laid out, each piece of plate steel is cut on a plasma table. No preformed tubing is used. While this process is automated, the next phase of the build is pure old-fashioned craftsmanship. The frame rails are bent and welded by hand.
From Grant, we headed to Goodlettsville, Tennessee to get some color and protection. Mr. Speed Coatings is a company that lives up to the name. In no time at all, we had a thick, glossy powder coat finish on the chassis. The color? Gunmetal.
Back at the shop, we began with the suspension. First, the control arms, followed by the four-link. QA1 PromaStar double adjustable coilovers featuring independent compression and rebound adjustment let us tune the suspension exactly how we want it. Next, a set of Wilwood Pro spindles. The solid rear axle received a Ford 9-inch rear end from Strange, along with Eaton differential and 410 gear ratio. 13-inch Wilwood brakes on all four corners provide massive stopping power.
The heart of this build is World Products Motown LS engine block, a hybrid engine. It accepts small block Chevy parts from the deck down and LS induction up top. An Eagle crankshaft gives us a 4-inch stroke. For pistons, we went with Mala's Power Pack kit. They are made from 4032 alloy for strength and durability. The pistons were mated to a set of Eagle's forged 4340 H-beam rods using ARP fasteners. A shot of duplicolor Cummins beige gave the engine block some retro 70s style. A custom ground Urson hydraulic roller camshaft was spec'd out with big duration and lift, and was complemented by their tie bar lifters. The Jessel belt drive assured us more strength, precision timing, and easy adjustability. The pickup, gasket, and Canton oil pan were all sourced from Summit Racing.
We installed a set of TrickFlow Gen X 260 LS7 cylinder heads. They are free-flowing and designed for big bore applications. Topping off the engine was an Edelbrock Super Victor LS7 intake manifold. It's built to handle over 800 naturally aspirated horsepower. Trend Performance push rods and 1.8 ratio Jessel rockers completed the valve train. With a Holley XP 1050 Ultra Dominator delivering the fuel, the engine produced 677 horsepower and 561 pound-feet of torque.
We made a minor body mod to fit bigger race tires out back. Detroit Speed mini tubs give us the extra room while keeping the stock appearance. XOR's Jeremy Weckman helped out with the bodywork.
The mini tubs include templates to help you mark exactly where the body needs to be cut. The factory wheel well is removed and the surface prepped for welding up a flange that will hold the mini tub in place. Holes are punched into the tub to recreate the factory spot welds. Then the tubs are welded into place. After a coat of seam sealant and paint, they almost look factory.
The RideTech Tiger Cage offers the protection needed in a race car. In addition, it increases the structural rigidity of the vehicle, allowing the suspension to react more predictably to driver input. Using a set of pre-bent tubing and clamps, the kit was installed in about 6 hours.
Fitting a 3-inch exhaust in a 73 Camaro that's already riding on a full-frame chassis, that's a challenge. If anyone was up to the task, it was MagnaFlow's exhaust wizard, Richard Wadis. Twin mufflers at the back give the exhaust a subtle, yet modern styling cue.
A 3.2-inch diameter carbon fiber drive shaft from QA1 kept rotating mass low and strength high. It's rated for over 2,000 horsepower. More carbon fiber arrived from Anvil Auto. They sent us a full complement of gorgeous yet understated body pieces. We liked the look of the matte finish on most of the panels, but couldn't resist going for the glossy finish on the cowl hood. Hoosier Sport Car DOT radials provide superior traction on the hot, dry surface of the racetrack. We chose the R-compound rubber designed for road racing.
It took countless hours, a ton of work, and plenty of high-performance parts, but this triple threat Camaro was totally worth it.
Now it's time to pound the pavement.
Up next, the triple threat Camaro gets a little loud and loose on its maiden voyage.
We have come to our fire department's training facility here in our hometown of Franklin, Tennessee to do a little shakedown on our triple threat Camaro. It's a big area and they have some cones set up and we're gonna see how much fun we can have with our new creation. The track is set up with a series of tight turns, including an optional 180 in the second turn. There are a couple of short straightaways, but it's mostly corners. In the middle of the track, there is a little area for doing donuts. We'll be certain to leave the Camaro's autograph behind. Well, it's painfully obvious. I'm a drag racer and I run out of talent immediately in a car like this. But all I know how to do is do donuts and act like a fool. So my producers have brought in a real car guy who's gonna show the true potential of this car. I have no idea who it is, so we'll see how he does with it. What's up? Well, I don't know who it is, but at least I'm taller. I thought this guy was supposed to be a real pro. Turns out, he's only a donut maker too. Oh, this is my hotshot driver right here.
Oh, well, they were gonna hire a professional driver, but Mario Andretti was already booked.
Well, that makes sense then.
Joey Logano was polishing his trophy.
Okay.
And Tanner Faust, he was closing on his winery today, so he couldn't make it.
I can believe that.
So, yeah.
That all being said, what did you think?
Oh, the car was amazing. I mean, this thing has way more power than you need, which I love.
Me too.
I like that. It's a burnout machine. Love that about it. And I really got to give you credit for leaving the vinyl top and leaving the paint the way it was, adding the new accents with the carbon fiber. Great look, great feel. Car stops on a dime. I'd like to see what this thing would do out on the drag strip.
It would be interesting. Yes, it's got plenty of power. It now does have a 410 gear in it, so it's a little spicy for like open road course. But for this type of thing, I think it'd be pretty fun to see what it would do.
I'm really amazed. I'm glad that you guys built a car to this level. Amazing, amazing job.
Thank you very much. Well, I'm just trying to keep up with you guys down there. So you guys got it going on too. I think it's time to get out of here.
Yeah, let's go. How about some donuts for lunch?
I like the sound of that.